Hello everyone. In this session, we are going to discuss about what is container runtime. If you are already familiar, you can skip this session. This is just for the folks who are just started learning about the containerization and everything. So, container runtime is an application which can manage the container lifecycle. Now, uh, we will understand what is container lifecycle. Spawning a container, creating a container, starting, stopping, mapping, networking, storage. All this is the part of container lifecycle. So, container lifecycle is for container management. Okay, so if the container image is available, container runtime application can go and create the container, start the container, stop, terminate, providing the networking to the containerized application, providing the storage to the containerized application. This is the container runtime application rule is. Container runtime application is only about container lifecycle. It cannot go and build the container image. Okay, so building a container image is a separate API which Docker or Podman they provide in different form. In the case of Docker, it is a build kit. In the case of Podman, it's a build AH or build A. Build A is the API which can go and build the container image. We will be discussing about Kubernetes, and Kubernetes is all about managing the cluster where the container runtime application is managing the container lifecycle. So we need to know what is container runtime. So container runtime, there are multiple providers are available. In the case of Docker, the container runtime is container D. We have CNCF also provides some certain container runtime they support it, like runc is there. Okay, so many container runtime is available. In case of OpenShift, that is Cryo. So this is the container runtime which is available. Again, as a summary of this session, container runtime is an application which can go and manage the container lifecycle. And in the case of container lifecycle, container image must be available. So it means your application must be available in the form of container image. Then only you can go and use the container runtime to create the container, to run the container, start, stop, terminate, and networking and other stuff. So container runtime cannot go and build the container image. So that is a summary of this session. Now let's go and understand in the further session why Kubernetes, what is the requirement and all these things. Thank you everyone for joining this session. Thank you. In this session, we will discuss what is container orchestration engine and why it is required. So container runtime is going to manage the container lifecycle for single host. So if a host, a Linux machine is there, a virtual machine, on top of that container runtime is installed, it can go and manage the container onto that particular host only. Across host, container runtime cannot go and manage the container lifecycle. In the PPT presentation, I'm using Docker as an example, but this is the limitation for the complete container runtime. So Docker run, or you can say the container runtime run single instance onto the single host. So it means if I'm running only managing the container using the container runtime, I will not have the scaling, load balancing, and clustering feature will be available for me. So container across cluster is the limitation, and for that reason we need something called COE, that is stand for container orchestration engine, and we have multiple solutions available for that, some such as Mesosphere, Docker Swarm, and Kubernetes. Okay, so need of container orchestration engine. Why we need it? Because container runtime is limited to the single host. When we discuss about the production grade solution, I need load balancing, I need high availability, auto scaling. All this thing is required replication. So container runtime is not capable to provide that in solution. So for that reason, if I want to go and orchestrate it, I will be using container orchestration engine. So Docker Compose is also one of solution is available. Those who are familiar with Docker Compose, but Docker Compose is also create the complete stack into the single host. That also cannot go across multiple hosts. So COE, Kubernetes is a COE, container orchestration engine. What we need it for set up the Kubernetes. So in layman term, Kubernetes is a tool, management tool, which can go and manage the pool of server where the container runtime is running. So these each color is representing a virtual machine. Each virtual machine is running Docker, and that particular Docker instance has the container runtime. So they are managing the container runtime. Now Kubernetes will be managing this pool of server, and it will be controlling the container runtime. It will be telling the container runtime which container has to be spawned, where exactly it has to spawn. All these things Kubernetes will be doing it for you. Okay, so Kubernetes is the management tool for that. What we need, we have a pool of server. Manually, we cannot go and manage the load balancing, auto scaling, and all these things manually. It is not possible. So rather than sending the request to the individual host, what we are going to do it, we are going to set up something like that, where one virtual machine where we will set up the COE, and in our session we will be setting Kubernetes for that. Other virtual machines where we will be setting up container runtime. And now Kubernetes will be taking the request and follow up the things that, okay, where exactly the container should spawn it. It will be taking the healthcare of the containers. It will be taking care of other stuffs such as replicas and deployment and other storage, everything. So Kubernetes will be taking care of that thing. So that is what exactly we are going to do it. Why Kubernetes? Because it is developed by robust. Many features are there. First of all, best thing is it is a API based solution. So it is API driven solution developed by Google. Internal project name was God. Okay. And now it is open source and maintained by CNCF. CNCF is Cloud Native Computing Foundation. So they are managing it. Okay. So Kubernetes is an open source container management tool. Kubernetes has the capability of automating the deployment and scaling of application and operations of application container across cluster, capable of creating a container-centric infrastructure. So currently, what you're seeing it, if you're using VMware or AWS, we are creating a virtual machine. It's a host-centric approach where we are creating the virtual machine. Inside the virtual machine, we are deploying the applications. But now, instead of deploying the virtual machine to run the application, we will be spawning the container, and then container will be running your application. So this is the container-centric approach. You are, whenever you talk about scale up or scale down, auto scaling or replication, you will be spawning the container for that. Okay, so that is the container centric approach. Kubernetes is an orchestration framework which deploy container in the unit of called pod. So we'll discuss in detail that what is pod, why it is required, and all this thing. Okay, so these are the Kubernetes architecture which we will discuss in the follow-up session. Just summarize the things. Kubernetes is a management tool which can go and manage the pool of server where each server is running the container runtime. Your request, whenever you want to create a container or you want to spawn a container, your request will be shared with container orchestration engine, and then it will connect to the container runtime and spawn the container for you. Kubernetes is the API driven approach. It has the API specified. They have the API created for each and every component, which we will discuss it. They have inbuilt API server will be coming with the COE engine, which we will discuss when we will discuss architecture, how this thing works and how the setup will be done. Okay, thank you everyone. Let's connect to the next session and we will discuss about the Kubernetes master component and worker node component. Thank you. Hello everyone. In this session, we will discuss about Kubernetes architecture. So Kubernetes architecture means Kubernetes is having a cluster setup. So we will be having a master or client server kind of architecture where container orchestration engine, which is Kubernetes, it will be setting up as a control plane on one of the Linux machine, and other Linux VM or virtual machines will be working as a worker node. So master, sometimes we refer master as a control plane as well, or you can say as a COE engine as well. So master, whenever you refer it, it means you're talking about the Kubernetes engine. Okay, Kubernetes COE engine. Okay, it has four components. One is API server. As in the previous session, I have explained you that Kubernetes is a API based product where each of the component has defined in the form of API. Then you have etcd, that is you can say is the database where exactly it will be storing all the component details, because we are creating a setup something like that where one virtual machines is there where you will be setting up the COE, or some people refer that as a control plane or maybe master, and all this component will be storing there. And then other virtual machines where you want to spawn the container, the component will be installed, respective component will be installed on that only. Okay, so this is the kind of setup we will be creating it up. So or etcd is the database scheduler. In the master, where exactly the container should be scheduled will be decided by the scheduler. Controller manager is performing the controlling mechanism. Like, okay, if I want to create three replicas of particular application container, then the three replicas are keep on running it. They will be always matching with what number of replicas has been mentioned in the control plane, that is taken by care by controller manager. There are multiple different type of controller manager will be available there. Similarly, worker node, this is another Linux machine. You will be setting up kubelet. We will discuss in detail container runtime and kube proxy. Here you can see I have mentioned docker forward slash container runtime. It means docker is not necessary must a container runtime. It can be anything. Container runtime can be container D. In case of OpenShift, it is cryo. So anything can be used as a container runtime. It must be recognized by CNCF that you can use as a container runtime application. This is the setup which mostly AV organization created. This is a master, control plane or COE. Okay, here all these components are there. This is another set of Linux VM. Okay, so Linux VM will be having one or more than one Linux VM. You can put it as a worker node depending on the workloads. So kubelet is there, this Docker or container runtime is there, and kube proxy is there. So we will understand why it is required. Okay, let's understand each component in detail. So as I initially mentioned, Kubernetes is an API-based solution. So whenever I will be creating or submitting some request, it will be in the form of API. So someone has to validate my API, and that is the component which is validating my API is API server. Whether you submit the request in the form of API, you are using web interface or you're using command line, all this request will be going to address by API server, because Kubernetes has predefined API that is in the define that definition is stored in the API server. So validation part will be taken care by API server. So if I say API server, what is API server? API server is the front end for the end user or for the system admin, whether they are requesting from any form, whether API, command line, or web interface or command line. Okay. So Kubernetes API server validates and configure the data for the API object, which include pods, services, replication controller, other resources. For now, these you can take as a Kubernetes API resources definition. We will discuss in detail what exactly it is. API server services are REST operation. REST operation is like get, put, post, delete, modify. All these operations they can serve it for the component. API server is a component of Kubernetes control plane that expose the Kubernetes API. So it means there are predefined set of APIs are available in the Kubernetes, which is the part of API server. So whenever you submit the request, the first thing will be part of the validation. API server is the front end for the Kubernetes control plane. It means as a system admin or Kubernetes admin or maybe end user, you will be interacting with the API server only. API, since this is a microservice architecture, it can scale up horizontally as well. Second component is etcd. Etcd is those who are coming from the Linux background. etc is in the Linux file system. Etc is a directory structure which keeps the configuration information about the Linux operating system. Similarly, etcd name inspired by etc only. Etc directory in Linux store the configuration file. D is for the distributed architecture, since the etc is a distributed configuration directory structure for Kubernetes. etcd is the open source project. This means it is not developed by Kubernetes. It is already available. You can go and Google etc. You can find it out. Store the metadata information for consistency and fault tolerant way. So if I suppose I create a container, which worker node the container is running it, what is the state, whether it is healthy or not healthy, what is the IP address, and everything will be stored in the etcd. So it stores the configuration data. It will be used for service discovery and cluster management. Okay. And master keep on monitoring the etcd and roll out the changes as well. Kubernetes persist cluster state into the etcd. So it means suppose I want to create this diagram. There is a container is running here, where exactly the container has created, what is the state, whether it is running healthy or not healthy. Everything is stored under the etcd. Similarly, worker node state, cluster consistency state, everything is stored under etcd. So API server will be monitoring the etcd to address the things. Okay. Then comes alternative of etcd, Zookeeper and console. Two other alternatives are also available, which you need to configure explicitly if you are not going for the default installation. Then comes to the scheduler. Scheduler, where exactly the workload should be scheduled in the form of container. That is taken care by scheduler. So control plane component that watches for the newly created pods, which is not assigned node, select a node for them to run out. Factors taken in the consideration is affinity, anti-affinity, data locality, inter-workload interference, deadline, hardware, software constraints. So many things are there, which we will discuss it when we will discuss about Kubernetes multiple different component and pod affinity, node affinity, label selector, taint toleration. I will be discussing in detail. Then important part comes is the kube control manager. Okay, for understanding purpose, it's a single binary. Okay, many different control managers are available for different purpose. As I told that, okay, replicas is like I want to run multiple copies of same application, so I can use the replication controller. Replication controller is the part of Kubernetes controller manager binary only. Its whole role is, if I mention 3 replicas must be created, it will keep on monitoring it. If one of the replicas goes down, it will again restart it. So different type of controller managers are available. Like node controller is there, job controller is there, endpoint controller, service account and token controllers. We will discuss each of the controller manager rules in detail when these APIs will come in the picture. Rest of the component like kubelate, kubeproxy, and container runtime, I will be discussing in the another session. So for summarize this thing, Kubernetes control plane or master has 4 major components. One is etcd, controller manager, API server, and scheduler. Sometimes it is master is referred as a control plane as well and COE as well. It is a virtual machine. Top of that, we will be installing Ubuntu or any other Linux player. And top of that, we will be setting up all this master component using kubeadm tool in this session. There are multiple other distributions are also available in form of Minikube, that is for learning purpose, or K3s distribution is also there, which you can use it. As a service also it comes like AKS, GKE and other things. We will discuss when we will discuss about the installation mechanism, what are the options are available. Thank you for joining this session. In this session, we will discuss about kubeadm. Before we discuss about kubeadm, you need to know that we are going to set up the Kubernetes cluster now. We have discussed about master and worker node, what are the components and other things. Now, we will be setting up the Kubernetes cluster. So for setting up the Kubernetes cluster, we are going to use a tool. The tool name is kubeadm. So what is kubeadm? Kubeadm is the tool to set up the Kubernetes cluster. Okay, so it's a tool which will be setting up the minimal viable Kubernetes cluster of production grade. Using kubeadm, we will be applying some of the best practices how to set up the Kubernetes cluster. So this tool will be setting up all the master component as in the form of container. Okay, we will see that thing as well. So using why to use kubeadm tool? First of all, it's easy to set up. Okay. Second is it's going to provide the production grade solution to you. Kubernetes kubeadm creates a full PKI setup. PKI stands for public key infrastructure setup. So even the Kubernetes component like API server, when it communicates to the etcd, is a full encrypted communication is there. There would be an internal certificate authority will be created, and each component will be having a private key and CRT for the communication purpose. kubeadm is a tool built to provide kubeadm init and join command. as the best practices fast path for creating the Kubernetes cluster. We will be using two commands, kubectl init and kubectl join. What init does it? Whichever Linux machine you are going to run the command kubectl init, it will set up the master component on that particular Linux machine. So kubectl init bootstraps a Kubernetes control plane node by executing the following things. What are the following things it will do? It will do the pre-flight check. Pre-flight check in the sense it will go and see the your virtual machine resources, whether the resources are available properly or not, whether SAP memory is switch off or not, whether the kubelet service is running or not. So all these things as a part of system validation part before the components are going to deploy it, they will be checking it up. So pre-flight check to validate the system start state before making the changes. Then it will be generating the CA, okay, self-signed CA to set up the identities for each component in the cluster. The user can provide their own CA cert as well. But in this case, we are going to use the default CA. And then it will write the kubeconfig file. Kubeconfig file, like all the master components, they will be setting up the configuration file, how the component should be created. All these things will be available there under etc Kubernetes. For the kubelet, the controller manager add the scheduler to use to connect to the API server, each of with its own identity, as well as additional kubeconfig file for the administrator account that is named admin.conf. So we will discuss this particular section in detail once the setup is done. Okay, it will be using a static pod concept. Static pod concept also we will discuss when I will explain you the pod, what is pod, how in Kubernetes, and then we will discuss this particular chapter, static pod manifest. Okay, how this kubectl is setting up your cluster. So static pod is the concept where all the configuration file will be there on the static location, and kubelet will be creating the pod. Basically pod is nothing but container in Kubernetes world. Okay, static pod manifest are written. Manifest means configuration file is written under this location, etc Kubernetes manifest, and kubelet watches is directive for pods to create as a startup. Apply labels and taint. We will discuss taint and tolerations. What is taint? How the affinity is working it out and all these things. Generate the token so the other worker node can join the cluster. So that token will be generated on the fly. Okay. So kubectl init will be setting up all the master component as well as bootstrap token. It will be generating it up. Writing a config file for making available all the information required for joining and setting the RBAC rule. Install the core DNS and kubeproxy component as well via the API server. Okay. So basic idea is kubectl is a tool which you need to install on your all the cluster virtual machines like master and worker node. In the master component, you will be running the kubectl init command. Init command will do the pre-flight check. Then it will be setting up the PKI, public key infrastructure, CSRTs. Then it will be creating a config file and installing the master component in the form of static pod using kubelet. Then comes to the kubectl join command. Kubectl join command is used to add the new worker node to the existing cluster, or whenever we create a cluster on the worker node, I will be running the kubectl join command. When initially you set up the Kubernetes cluster, kubectl init command, you run it, it will generate a unique token. This token is required for the worker node to join the cluster. So you will be running kubectl join hyphen token, control plane IP, port number, and discovery token CSRT hash. After executing the join command, the worker node will be establishing the connection with the control plane. It will download the necessary component and dependency to become the part of the Kubernetes cluster. So we are going to use this tool, and on master or one of the Linux machine, you will run the kubectl init command. Whichever Linux machine you run the init command will set up the master on that particular machine only. The respective rest of the virtual machine, you need to run the join command, and the join command will join the cluster. Okay, so join command you need to run on the worker node. So this is the some session about kubectl. Now, before we proceed for the further topics, I will explain you the kubectl in the next session, and then we will progress with the setup. Thank you for joining the session. Hello everyone. In this session, we will discuss about the worker node components. So in the previous session, we discussed what are the master components. The master components is like etcd, API server, scheduler, and controller manager. Similarly, Kubernetes worker node. Worker node means where your workload is going to run it. So your container will be hosting or running onto the worker nodes only. So you need container runtime. In this diagram, you can see Docker as the red, kubelet, which is agent. So whenever master receive any request, it has to communicate to the uh, worker node. So kubelet is that agent through that master will be communicating it. Then there's a networking component is there, which when we will discuss Kubernetes services, we will discuss about this component, but that is kubeproxy. Let's go. I already explained you what is container runtime. So container runtime in our case is Docker, which is about supposed to run the container lifecycle. Now, kubelet is an agent which that runs in each of your worker node in the cluster. It makes sure that containers are running in the form of pod. So what kubelet do it? Kubelet takes your request, takes a set of pod specs that are provided through various mechanisms and ensure that container described in the pod specs are running and healthy. Kubelet does not manage the container which was not created by Kubernetes. So kubelet cannot go and manage the container which is created by Docker CLI or any other way. It will not do it. So explanation purpose, if I create a container using Docker run command, then that will not be managed by kubelet. So kubelet will only manage the container which is created through Kubernetes. Then comes to the kube proxy. It is a network proxy that runs on uh, each node in your cluster, implementing the part of Kubernetes service concept. So we will discuss in detail what is Kubernetes services and how kube proxy is working it. So it's a in an easy way you can understand kube proxy is the implementation of IP tables, so like set of rules with where the traffic should go, where the traffic should come, how the traffic forwarding will happen, network port forwarding will happen, if any kind of packet manipulation is required, how we'll do it. All these things is implemented using kube proxy. So it's maintain the network rule. In network rule, what we do it, if I talk about IP table, we do the filtering, we do the forwarding, and we do the mangle with like packet alterations, which we say. So all this thing we do it under the say IP table. Same implementation we are going to do it using kube proxy. So the network rules allows network communication to your pod from the network station inside and outside of your cluster. So proxy is very important component and for for sending your traffic from a container to the outside world and receiving from the outside world to your containerized application. Now we know what are the components we are going to set it up. Now what we are going to do it, we will be discussing about a tool called KubeADN and how to set up the cluster using KubeADN. And similarly, further lines, we will discuss about kubectl and what is the kubectl thing, how it works, and what are the things are there. Okay, so in this session, we learn about worker node component. One is container runtime, which will manage the container lifecycle, kubelet, which will be receiving your master request and updating the master what is happening in the worker node. And kube proxy, it's a networking component which will be taking care of filtering, forwarding, and packet alteration. All these things will be taken care by kube proxy. Thank you for attending this session. In next session, we will discuss about KubeADN. In this session, we will discuss about kubectl. What is kubectl? Kubectl is a command line utility to interact with the Kubernetes API server. So whenever a user want to communicate with the Kubernetes control plane and get some information or want to create some component, they need to use a command line utility. The kubectl is the kubectl or kubectl is the basic command line utility to interact with the master. There are other ways to do that thing as well. OpenShift provide utility called OC. They have the web interface as well. Rancher also has the same kind of web interface available there as well. Okay, so overview of kubectl. This is the command line utility tool. You can pronounce as kubectl or kubectl. Allow you to run the command against the Kubernetes cluster. Okay, we can use kubectl to deploy the application, inspect, manage the cluster resources, view the logs, get the information, describe the component for troubleshooting purpose and all this thing. So viewer wise, when you want to see how the kubectl or kubectl look like, kubectl, it will interact with the API server and then it will get the information for you, get or maybe create or delete the resources for you. Okay, you can set up the kubectl. The binary is available for that. You can go and set up in all the component, all the cluster components, like all the worker nodes, if you want to set it up, or anywhere remotely also you want to access it. You can use kubectl to communicate to the API server. So these are the basic things which you should know it before we proceed for the component cluster creation lab. So in the next session, we are going to use the uh, Docker as a container runtime and setting up our Kubernetes cluster as well. Okay. So thanks for joining this session. It's just a small brief about kubectl or kubectl, which we will be using it in the upcoming session. Thank you. Hello everyone. In this session, we will discuss about how to set up the virtual machine in your personal laptop. So you need to download the VMware workstation or you can use the Oracle VirtualBox as well. I'm using VMware workstation for Windows 11. Okay, download from the official website, and then you can download Ubuntu 22 or 24 up to you server edition. You need to download the server edition. So this example I am taking 2204, but if you want, you can download 2404 as well. You will be once the workstation is downloaded, you will install the VMware workstation. It's just a exe file. Just next. You will do it and do the default installation. Once the installation is completed, you will open the VMware workstation and you will get the option create a new virtual machine. While creating the virtual machine, select the option custom, press next, and here you will be selecting the ISO. So Ubuntu ISO, like I have 2404, I have downloaded it. So browse that one and next it. Okay, give any name, provide a drive where you want to create the virtual machine files. Okay, So I have taken C drive, 2 CPU I am giving it, 4 GB RAM I am giving it. That's enough for us for the learning purpose. Networking type, you will be selecting network address translation. Don't go for bridge and any other thing. And default ID like LSI logic driver and SCSI I'm using it. Creating a new virtual machine, and I'm giving the size 50 GB. 50 or 60 GB is good enough. Store as a single file. Otherwise, it will create the 2 GB small files. So I think you go restore store virtual disk as a single file. Okay, and finish it. Once the thing is done, it will come on this prompt. Okay, this is the black screen prompt. You will get it, and try to install the Ubuntu. I'm using US English. Go for that, and Ubuntu server, I'm installing it out. Taking the IP automatically, it will assign the IP because I have used net, so it will automatically take the IP. No need to press any proxy or anything. Go and install it. Once it comes on this window, select the drive 50 GB one. Okay, format it, and it's asking for the formatting and provide the username password. Okay, so username password, you need to remember it. What username and password you have given it, and then you can go and install the OpenSSH server as well, because we will be connecting through the putty, remote connectivity putty, or any other SSH tool. We will use it to connect to the Ubuntu VM. So I'm installing OpenSSH as well. And minimal installation, you need to do it. You don't need to select any of these packages. Once the installation is completed, reboot now. Once the reboot is completed, log into the machine and run the command, or otherwise on the prompt only, you will see your IP address. This IP address just note it down, because through that only we will be connecting to our Ubuntu Linux VM. So that is the lab you need to perform first. Set up the environment. If you already have the Ubuntu VM, no need to proceed with the step. If you are creating in the cloud, please use the Ubuntu environment, because all the follow-up steps are based on the Ubuntu environment only. So I will suggest, if you are using AWS or GCP cloud, you can go and select the virtual machine there, EC2 instance type, select the Ubuntu template 2404 server edition, and connect through keys, and get the public IP and connect through the keys. Okay, so that's also you can do it. I need a Ubuntu VM. Single VM is good enough for us. Generally, worker node, master node, minimum 2 VMs are required, but currently we will use master only. Inside the master only, I will set up everything. So even though we don't have a good like configured laptop, minimal 8 GB and 4 CPU laptop, we can go and do this setup. So you don't need more resources, hardware resources. Like the virtual machine configuration is 4 GB and 2 CPU. So I think most of our latest hardware has that configuration. And currently the post Windows laptop, my laptop is having Windows 11. So Windows 10, Windows 11, or if you are using Mac, that is fine. Okay. So that's it from the lab number 1. We will be having a lab 2 and lab 3, where we will be doing Docker setup as well as the Kubernetes setup as well. Thank you guys. Thank you for joining the session. Hello everyone. In this session, we will be setting up the Docker CE edition, community editions, which is the open source one. And in this whole training session, container runtime will be provided by Docker only. So as in the previous session, I shown how to note it down the IP address. Now, those who are not familiar with Linux environment or anything, PuTTY is a utility to connect Linux environment remotely using SSH protocol. So we will be downloading the PuTTY, or if you are using some other tool to connect it, you can feel free to use it. This is the website. Download PuTTY. You will click it, and you will be downloading the exe. Exe don't need to install it. It's just directly executable. So just download the exe, and once you click on that, you need to provide the IP address of your virtual machine, and then use the protocol SSH. Port number need not to be changed. It will give you a message, accept it, and now it will prompt for the username and password. Please provide your username and password, and now we are good to go. The first thing which you are going to run, the commands and the script which we need to run it, it will be provided in this rectangle box only. So followed by the screenshot how I done it. Sudo apt update. So what this command is doing, it is downloading the metadata information of the latest bundle which is available on the official website of Ubuntu. So it will download that information. Then once this is done, we are installing uh, the HTTPS and CA certificate, curl, and software properties common module. Why we are doing it? Because we want to use the signed repositories. So install these packages. Once the package installation is done, then we are downloading the GPG key for Docker repository. So if I want to use the signed repository, or basically what is the meaning of signed repository? Means the package will be coming in the encrypted format. Using this GPG key, they will go and decrypt the package. So there is no man in middle attack will happen. The package will not be vulnerable. It will be coming in a secure environment. That's the reason we will be downloading this GPG key and mapping the Docker remote registry. So there is no output for this. Just run this command like this. And similarly, I just show you here in my putty environment. I just simply run it. It will not generate any output. It is just creating, downloading the key and mapping to the etc apt sources.list d sources list d folder only. Okay, once this is done, now we are installing the Docker. Okay, this is Docker, if Docker ce, Docker ce cli and container d. So we are installing these packages. Once the installation is completed, you will be able to run the command systemctl status Docker. Okay, so it will show you active running. Currently I'm using root user. So if you want to use the root user for follow up this, you need to run the command sudo su. It will prompt you for the username. It will prompt you for the password. Provide the password for your user. That's all the thing you need to do it. Like I have the user called Amit is there. Okay, I'll just show you. I have called user called Amit is there. Okay, so Amit user has the password. I'll just do the sudo su. It will prompt for the password. I will provide the Amit user password here. And now the user is root. If you are using root as a user, then you don't need to use the sudo in front of any command. Even if you are using it, there is no harm, but no need to use it. You can directly run the command apt update or apt install, because root is the super user in case of Linux. So this is the way you will be setting up Docker CE edition. Okay. Once the things is completed and Docker is up and running, active is running, then we are good to go and set up the Kubedium stuff. Thank you guys. Thanks for joining this session. Let's connect to the next session and discuss about Kubedium. Hello everyone. In this session, we are going to set up Kubedium, kubectl, as well as Kubernetes control plane. So steps are documented. I will just explain the steps and you just need to go and connect to your Linux VM environment through putty and copy and paste these commands. So first of all, I have logged in as a root user. Okay, you can see it here in my Ubuntu environment. I'm on the root user. Now, the first command which I'm running it here, what exactly it is doing it in the Linux environment, I'm all loading two modules. One is overlay module and second is net filter module. So these two modules, one is for overlay driver, that is each container will get the IP address. So how it will get it? So there is a overlay driver, we are loading it up. Net filter is for proxy purpose, so we are setting it up and we are enabling the bridging for IPv4 and IPv6 both. So I'm just copying and pasting this command as is. You can also do the same thing, copy and paste it. That's it. Now once this is done, now similar thing as I told, we are going to use the signed repositories. In the Docker case also I have used the signed repository. Similarly for Kubernetes also I'm going to use the signed repository. I'm installing three uh, packages. One is kubelet, kubedium and kubectl. So all this thing I'm doing it, you can copy and paste as is and it will go and set it up the environment for you. So once this is done, it will go and install kubelet, kubectl and kubedium for you. And once this is completed, then you can go and check the version. It must be 1.30 or 1.31. Now we are switching off the swap memory. Why it is required? Because kubelet is a service which will only run when the swap memory is switched off. Okay, so swap memory generally in the operating system, why they use it when they are running out of memory, swap memory will be used to store the in memory processes. So in that case, it degrade the performance. So in Kubernetes architecture, they intentionally done this thing. So that's the reason swap memory must be switched off. So I'm just switching off the swap memory. Okay, once this is done, then we are telling Kubernetes which container runtime I'm using it. Okay, so I just switch it off. Now I'm telling the Kubernetes which container runtime I'm using it. So here, as I told, I'm using Docker. Docker has the container runtime called containerd. As you can see it here, I just show you systemctl status Docker, and you can see here the container runtime is containerd. So we are telling Kubernetes architecture which container runtime I'm using it and mentioning into the file. Okay, so this command you need to run it. Okay, this command you need to run in the worker node as well. Step 1, 2, and 3, which I have performed it. If I am you are using multiple Ubuntu machines, one is for control plane, other for worker node. Step 1, 2, and 3 you need to perform in each of your worker node. Step 4 is the one which you need to only perform in the master node or in the control plane node. So step 4, what is there? Step 4, what we are telling is I'm running the command kubedium init command. I'm running it. Okay, so this command is there. One second, just give me a second. Okay, so step 4 is the command where we are running this kubedium init command, kubedium init hyphen pod network cider, and we are giving the network space for that. Okay, so this command we are running it, and you can run it kubedium init hyphen pod network cider equal to 10.244.0.0.16. This specifically this part, what is exactly is doing it? It is providing the IP range for your pod. In the sense, in the container, whatever IP I'm using it, it is providing the IP for that. Okay, so let's go and run this command. Once this command is completed, sorry, just give me a second. Actually, my Kubernetes cluster is already set it up. So I just reset the environment and run this command again. Now, if I run this command, it will work. So what this command will do it will first go and do the pre-flight check as I initially mentioned. Then it will go and create the PKI setup. Then it will create the configuration file. You can see it configuration file, PKI setup. And now it is starting the Kubernetes cluster. Once this part is done, now the next part is you will be copying the admin.conf file into your user home directory. So currently I am using root user. So root user home directory will be there. If you are using your own user, like if I am using Amit user, in the Amit user home directory, I need to copy the config file. Config file, this admin.conf file, what it contains, it contains the Kubernetes administrator, you can say the authentication mechanism. Okay, authentications are there in the form of key and cert. So these three command you need to copy and paste it. Otherwise, kubectl command, every time when you run it, you need to mention the things. Okay, you need to mention the admin.conf file. Why I'm telling it, like I run the command kubectl get nodes, is working perfectly fine. If I go and remove this file from the location, okay, now if I run this command, it will fail. It will give the error message that okay, I could not find the API server. So that's the reason you need to copy your etc kubernetes admin.conf file in the user home directory. Currently root user is there, so user home directory.kube folder, you need to copy it. Once you copy it, you can run the command. Or other way to run this command is you can run the command kubectl and you can mention kube config and you can mention etc kubernetes admin.conf. Each command you need to mention this thing. It will work that way as well. Once this is done, it will be showing not ready for you. You need to go and install the CNI. CNI stands for Container Network Interface. This is the plugin which will be enabling the IP for your pod. So your pod will get the IP from the range, but the plugin will provide the interface to that. Okay, so you go and install. I'm using Fennel here. You have two choices, Calico and Fennel. I can go and install the Fennel here. So I'm just installing the Fennel. Okay, once the final installation is done, now if you run the command get nodes, after some time it should show you ready, and the role must be control plane. That's the only thing is there, and must be you must be seeing 1.30 version or 1.31, which is the latest one. It will install it, and it will show you ready. So this is the part thing you have done it. Now we want to use what do you say, master as a worker node as well. I want to run the container in the master as well. So we need to remove the taint. We will discuss taint in further session. What is taint, why it is there, and how you can use a tainted node. But currently we need to untaint the master. So you will go and grab the taint value. You will run the command like this. It will show you the taint value. Okay, this is the taint value. This is the name of the server. You will run the command kubectl taint node, name of the node, Amit server. In your case, it will be your Linux machine name. And this taint value you need to copy and paste it here, followed by hyphen. It will untaint it. Now, if I go and grab the taint, nothing will come there. And this is the way you can use the master or single node setup in your environment. So basic idea is that one. One key note here is every time when you power off your virtual machine and powering it on, please make sure you are switching the SAP memory, because by default SAP memory, if you don't switch off, kubelet service will not start, and if kubelet service will not start, your master component will not be running it. And second key thing you can take care of, don't shut down the VM, you can suspend the VM. Okay, so right click and you will be having the option here where you can go power and you can suspend the guest. Suspend will not crash the master component and your environment will be up and running. So this is the couple of key points you can note it down. And that's it from this topic, how I set up my Kubernetes cluster. Thank you, everyone. Thanks for joining the session. Session, welcome back. In this session, we will be discussing about Kubernetes APIs. So as I initially mentioned you that Kubernetes is an API based product where each and every resource in the form of API, they are predefined set of APIs which is already available in Kubernetes setup. So in the control plane setup which we have installed in the previous lab, you can run the command kubectl. As I mentioned, kubectl is the command line utility for Kubernetes. You can run kubectl API resources and you will see list of API which is already available in your Kubernetes setup. In that, it has name of the API, short name of the API, API version, namespace, and kind. So they are defined it here. Okay. So you can see API version is v1 v1 v1, and then it is admission registration followed by v1 apps v1. So different API groups are there. Each of the API resource which is defined in Kubernetes is the part of some API group. Okay, so is it as I mentioned that Kubernetes API, Kubernetes control plane has the API server, and that API server contains the definition of that. And we need to stick with the API version and the kind. So whenever I want to go and create any type of resource in Kubernetes, I will be mentioning what kind of resource I want to create it and what is its version. That is what exactly we will be writing it out. So, and there is another thing is coming here is namespace. Somewhere you see namespace true, somewhere you see namespace false. So namespace concept we will be discussing in the upcoming session, but uh, most of the resources are namespace resources. So we will be creating by default inside the namespace. So you run this command kubectl. This is a command line utility and API-resources. This will list out all the APIs. You can see the version and the kind there. We will discuss in the next session what is namespace, and after that we will see how to write the YAML file. So in this summary session, you can go and check it out. What are the native APIs which Kubernetes is providing it? So initially, when I mentioned the control plane has API server, it means this definition is already with the control plane. Whenever you will submit the request, that will go in the specific version, kind, all these things will be mentioning while you are submitting your request, which will be validated by the API server. Okay. So thanks for attending this session. In next session, we will discuss what is namespace, and then we will see how to explore your current running cluster. Thank you, guys. Hello everyone. In this session, we are going to discuss about YAML. Why we need to know? Because in Kubernetes, whenever you want to create any API resource or modify any API resource, you need to submit the request in a specific form. So that form is supported in the form of YAML or JSON. In this training session, we are going to use YAML. YAML stands for yet another markup language. Why we need YAML form? Because that will be giving you a standardized form. So like you can imagine this thing in this way that okay, any official document when we fill it up, it comes with the standard format. Same way, when we want to submit our request for any object creation or modification in Kubernetes, we will submit in the YAML format. It is a standard form which we will be submitting it out. Now YAML, the extension will be YAML or YML. Whenever you create a file, you can provide either one of them the extension in the form of extension. Okay, we need to provide three values. One is mostly many things are there, but in this session, you should know how to pass the key value. There is left hand side, the key is there, followed by the colon, space, and the value. This is the key value. If there is an array or list, this is the name of the array like fruits, and the item or the objects of the array, it will start with the hyphen. Okay, that is array or list. Then comes the dictionary or map. You have a name of the dictionary and multiple key and values are coming there. So these are the three things you should know about the YAML: how to pass the key and value, how to define the list or array, or how to define the dictionary and map. One another thing is YAML is indentation base. Basically, spacing define the scope in YAML. So in this case, if you provide space, like under the array, if I want to list the item, they should come with the same spacing. So array items or list items are coming in the same spacing. So that is what you need to take care. In the YAML, space will be uh, making the difference for the scope. And another thing which you should know is like don't use tab, use the spacebar when you are coding it out. So that will help you out to code it easily. Now, this is the basic of YAML, and then we will start coding it out. You will more learn about the YAML, how to use it, and how to define the things. Okay. Thank you for joining this session. Let's connect to the next session and start our first resource, that is namespace. Thank you. In the previous session, we discussed about YAML. So in the YAML, what we will be writing it out? We will be discussing this part here. So in the YAML, when I will want to submit the request form, we need to send it in the specific format. So first of all, what kind of resource we want to create it. So suppose I want to create something called pod. We will discuss what is pod. But if I want to create something called pod, so the pod will come with the API version and all these things, correct? So if you go here and see the API resources, you will see certain sections are there where you can see the API version is there, then you have the kind is there. So all these sections we need to define in the YAML. So most of the Kubernetes resource, not all of them, has the four major sections are there. First is API version. Which API version you want to use it while creating it? API version depends on what kind of resource you want to create it. Suppose I want to create a pod. So the kind define which API version I want to use it. Suppose I want to create pod, then I should go and see what is the API version for the pod. So if I go here and see a little bit down, pod, and I'll see API version is V1. So pod has the API version V1. That is V1 is the API version for the pod. Okay. It's there is no V2, V3. It's a static thing. It's predefined. Okay. So API version is the static thing which is defined by Kubernetes API server. It's already defined definition is there. Kind type defined on the kind of resource I want to create it, API version will come. Then the name metadata section will come where you will be providing the resource type specific information such as what type of what name you want to give to the resource or which namespace you want to create it. So suppose I want to give some name to the resource, I can give there. And the spec section contains the specification about the resource, where exactly what image you want to use it, any specific resource related information. All this comes under specific section. So it means four sections are there: AKMS, API version, kind, metadata, and spec section that you will be defining in the YAML file. Depending on the kind of resource, the API version also will vary and the spec section also will be varying it out. Is it the four section are static? No, the four section spec section, sometimes there is no spec section. It will be directly data, string data, and depending on the resource type, the four section will be varying it out. But major most of the resources in Kubernetes has the four section AKMS, where API version, kind, metadata, and spec section you will be defining in the YAML file, and then you will be submitting this YAML file to the API server. So this is about Kubernetes uh, YAML file definition. We will go and discuss each of the component in detail and see how we can use this four section and write our own YAML file. Thank you for joining this session. Hello everyone. In this session, we will discuss about the resource type namespace. If you go in Kubernetes environment and search for kubectl API-resources grep for namespace, you will find there is a resource type namespace is available. The short name is NS, the API version is V1, namespace object is false, and the kind is namespace where N is capital. What is namespace is? In Kubernetes, we are creating a cluster. Now, if I want to divide the cluster resource or logically divide the cluster resource across multiple teams, I will be having a concept called namespace. So in Kubernetes, namespace is the mechanism for isolating groups of resources within a single cluster. So you will see when I am running this command API-resources, somewhere you can see that the namespace type is true and false. So wherever you are seeing true, it means that particular resource will be created inside the namespace only. Wherever you see the false, it is a cluster resource. It will not be created inside the namespace. So namespace is the mechanism for isolating group of resources within a cluster. So suppose you have three teams, team A, team B, and team C. They all want to create the container in the same cluster only. So using the namespace concept, we can divide their pool. Okay, so that is what exactly namespace is doing it. Name of the resource which we are going to create it must be unique within a namespace. Across namespace, you can provide the same name. Some resources which are uh, not namespace bounded, where you can see the false, it means they are not the namespace resources. They will be creating across cluster. You can run the command kubectl API resources namespace equal to true to see the which resources are namespace based resources. Okay, API hyphen. mm, okay, so it will show you which resources are namespace type resources. Namespace are intended for use in the environment where many users or multiple teams are working it out. So that will scope it out that team wise, we can provide the access as well on the namespace level. We can filter the resources, which team resource belong to which team. So all these facilities will be available there. Namespace cannot be nested. It means one namespace cannot hold another namespace. That is not possible. Avoid creating a namespace with the kube hyphen command. That is exactly you should not do it. Okay, I can show you the command kubectl get ns. You can also use it. That will list it out what are the default namespaces there. So you can see cube hyphen system is there, cube public is there. So whichever is starting with the cube, they are Kubernetes default namespaces, which is Kubernetes has created for the setting up your environment. There is a default namespace is there. If I'm creating any resource, I don't mention the namespace, the resource will be created inside the default namespace. Okay, how I can create the namespace? Simple thing. You can run the command kubectl create namespace and give the namespace name labs. That will also create the namespace kubectl. get namespace, if I do it, it will show me, or either I can write the YAML file as well. In the YAML file, you will be mentioning these things which I have shown you here, mm, where you will be mentioning API version, metadata, and this thing. So I'll just show you NS YAML file name. You can give anything. I'll just say API version, okay, space v1, then uh, kind, what kind of resource we are creating, namespace. I told you N is capital there, metadata, name of the namespace. Like I want to create dev. So if I create this YAML file, what I need to do it, I need to use kubectl command to create the namespace. How will you do it? Kubectl command will be providing the option to create the resource. So you can use the command create and then -f name of the YAML file. What exactly this command will do it? This command will read this YAML, provide this, submit this YAML file to your API server. API server will validate this YAML file and see whether the resource is already there or not. If it is not there, it will go and create it. See. So both the way you can do it. I will be providing the lab details for both the things, how to create the namespace using command line and how to create the namespace using CLI option. You guys can go and check it out, my lab details as well on this link, which I will be sharing it out here. Okay, this is my lab link where you can go and check it out, how to create the namespace. So here, both the options are available. Create the namespace using CLI and create the namespace using YAML file. So you can perform the lab number 2 and lab number 3 in this session and let us know your feedback. Thanks for joining the session. Thank you guys. Hello everyone, welcome back. In this session, we are going to discuss about pod. Okay, in Kubernetes, uh, as I explained to you that everything is in the form of API. So if I want to create a container Kubernetes, the minimal resource which I want to create it, I need to create it, that is pod. Okay. So in Kubernetes, pod is an entity which will be holding your container. Okay. So whatever container runtime you are using it, ultimately, whenever you want to run a container, that will be is in the form of pod. Okay. Yesterday I explained you in the previous session that API version, kind, metadata, and spec. This is the thing you need to write in the AKMS folder. Now, API version, this defines Kubernetes API that we need to use in the YAML. Okay, depends on the what kind of resource you want to create it. Metadata, this is identity for the object, like the user want to provide the name, which namespace you want to create it, what labels you want to provide it. All this thing goes under metadata. Stack section, specification for the particular thing. Okay. Now this is exactly the scenario looks like. You will be submitting the request to the master, and from the master it will be having the API server will take your request. Then it will go and check under etcd whether the resource is already there or not. If it's not there, asking the scheduler and schedule your pod inside the worker node. So pod are the smallest deployable unit of Kubernetes computing that you can create and manage in Kubernetes. So basically, whenever someone wants to run a container in Kubernetes, they need to run in the form of pod. A pod is group of one or more container. A pod can hold one container and more than one container with shared storage and network resources and a specification for how to run the containers. Currently, the first example which we will discuss it, we will be going to run one pod. Inside that one pod, we will be only running single container. Later on, we will discuss multi-container thing as well. While Kubernetes support container runtime like Docker, we are already using it. You have containerd, cryo, Docker engine, many container runtime is there. Pod that runs single container. It's a good practice, one container, one pod. This is the most common Kubernetes case. So you can think of pod is a wrapper around a container. So whenever someone says, I want to run a container in Kubernetes world or Kubernetes environment, it means they mean to say you want to run the pod. Okay, so let's go and see how it looks like. And I will suggest, please go and type the YAML file rather than copying and pasting. So you will get the clear picture how the things are working it out. So first of all, the command which have used it, API-resources and grep for pod. Okay, let's see. So this is the pod. The kind is pod. API version is v1. Okay, you can go and use the YAML file. Okay, YAML file. I just run the ram testpod.yaml and I'll give API version colon v1. Then kind will be pod p capital. Then metadata name of the pod. So I'll just say name first pod. Okay, this must be all small letters. Kubernetes RFC says the name of the object or resource must be in the small letters only. Then spec. Under the spec section, what we are creating it containers. Okay. As I mentioned, pod can hold one or more than one container. So it means containers is a list or array. So I'll just say name of the container. Okay. Test container and the image which I want to use it. Image, you can check it out on the hub.docker.com, whatever container image you want to use it. I'll just say Nginx, latest one. Nginx is a web server container. I'm just using that one. Okay, that's it. I'll just say kubectl. Kubectl is a command line utility. Whenever I want to create any resource or modify any resource, I will be using kubectl with create or apply command. So I'll just say create -f name of the YAML file. I just say testpod.yaml. The moment I do this thing, the pod has been created here. Okay, I just go and see get pods. You'll see there is a pod is creating, container creating is coming here. I just say kubectl describe pod and name of the pod. Okay, first pod. You see that pod is pulling the image. Point you should observe it here is it describe will give you the event section. The event section is important. Here you see that first scheduler has come, it has assigned the worker node to me. Currently, only one server is there. Summit server has been assigned. Now, kubelet is coming. As I told initially, kubelet is an agent in Kubernetes which will receive your request. So, kubelet has received this request and pulling the image. But here only the one point you should observe it. It is not exactly kubelet who is doing it. This thing. It is container D who is doing that thing. Okay. If you go here, scroll up, you see the container runtime is also visible here. One second. I'll just show you. Let's see. Okay, it's started running it. Uh, yeah, here you can see that the container D is a container runtime. So how the flow is working here is similarly like this, somewhat like this. You will be having uh, submitting submitting your request using kubectl command, kubectl create -f command to API server. What API server is doing it? API server first go and check in the etcd whether the resource is already created or not. If it receives say that no resource is not created, no resource is not created, API server will go and communicate to the scheduler. Then scheduler will assign. Here you can see scheduler is in the event section. You can say default scheduler has assigned a worker node to me, and then kubelet scheduler assign the node, and then task will be assigned to the kubelet. Task will be assigned to kubelet. Basically, task is what? The pod spec file. Spec file in the sense like which image has to be pulled it up, what is the name of the container, all this thing will be assigned to the kubelet. Now, if you see here in the event section, kubelet is pulling the image, kubelet is pulled the image, kubelet has started the container and all this thing. But how kubelet is doing it? Kubelet is using container D to do this thing. So container runtime is the exact thing who is managing the container lifecycle. As I mentioned, container lifecycle where you start the container, create the container, start, run, all this thing is a part of container lifecycle. So basically kubelet is controlling the container runtime now. So this is the command you can use it. You can similarly go and delete the pod. Okay, I can go and delete the pod as well. And this is so sorry, first pod, name of the pod is first pod. So these are the things which you should cover it. You should know it, that okay, how the pod lifecycle works. And troubleshooting, first level of troubleshooting is always with the describe command. Whenever you run the describe command, go and check the event section. Most of the time under the event section only you will find it out what is the issue is happening here. Okay, so basic first level of troubleshooting is start from the describe command only. Okay, thank you guys for joining this session. In the next session, I will be sharing the lab and providing you the YAML file detail, which you need to type it yourself and perform the activity. Thank you. Thanks for joining this session. Hello everyone. In this session, we will discuss that the pod can hold multiple containers. A single pod can run multiple containers together. But if you read the definition, a pod can encapsulate an application composed of multiple co-located containers that are tightly coupled. Tightly coupled means they must be correlated. One can be a web server and second one will be web server data provider. That kind of container you can tightly couple because they need to share the storage, they need to share the networking, all this thing they need to share it. So it means if the applications are not correlated, it is not recommended to create the multi-container pods. Always create the multi-container pod when the applications are correlated. The pod wraps these container storage resources and ephemeral network identity together as a single unit. So it means these pods, when they are holding multiple containers, they are sharing the resources. And when they are sharing the resources, it means the application must be the application container must be correlated with each other. So best example I can give you the tightly coupled one is, suppose one is a web server container which is publishers, like it is holding the website. Okay, website holder container is there, container. Maybe Nginx example you can take it. And the second container is the data feeder. The data feeder is basically it is feeding the data to the web server. So these are the tightly coupled. Other example which you can take it, the container, one container which doesn't have the no relation with other container. Like I have my MySQL and other container I am using Postgres. So both are database container. You will be complicating the your multi-container pod itself. So don't create the multi-container pod when the applications are not correlated. The application must be correlated. One will be helper, second will be the main application container. Basically in the service mesh, we use the multi-container pods. But normally, if I don't have any correlation or I don't need it, always go with one container, one pod. Don't go for multiple container, one pod. Okay. So if we have that, some people have that understanding that if I create the multi-container pod, it is about the resource utilization. Answer is no. It is not about the resource utilization. It is how I want to create a correlation between the applications. Okay, so I will be showing you the lab part. You guys will be, I will be sharing this link. This has already YAML file is created by me only. I already shown you that how to write the YAML file. So you will clone this Git repository. Okay, and you will be performing lab number two. In the lab number two, there is a YAML file is already there, devpod.yaml. Okay, so git clone when you do it, I'll just show you in my and development environment git clone. In my Linux box, I will do it. So it will create a KTS folder. You will go in the KTS folder and you will find devpod.yaml file is there. So it is creating a pod, okay, inside the dev namespace. So first make sure that you have dev namespace is created available there. If it is not there, it will fail. So this is first exercise you will be doing it. Create a pod into a particular namespace. So and when you are getting the pod information, see, I'm mentioning the namespace name. When I am describing the pod, also I'm mentioning the namespace name. Otherwise, it will go and try to find the pod into the default namespace. Second example is a multi-container pod example. Okay, in this example, what we are doing it, mm, we have two containers there. One is Nginx, second is web server. Sorry, first is Nginx, second is busybox. Two containers starting it out. What I'm doing it here is I'm just creating the container, describing it, how it is working, going inside the exec kubectl exec command. It will go and execute the particular command inside the container. So since this pod has holding two container, if I want to connect one container and run some command, I can do it. Second container I want to connect it, I can do that way as well. So these are the two labs you need to perform it, lab number 2 and lab number 3. Okay. And as a part of this thing, again, I will just summarize it. Multi-container pod, you will only create when the applications are tightly coupled, when they are correlated. Again, don't go for the resource utilization that, okay, it is about the resource utilization. We will make the resource utilization. No. Okay. So this is a summary of this session. Thanks for joining. In next session, we will discuss about, I'll summarize the init containers and give some assignment to you for that. And then we will proceed with the other workload APIs. Thank you for joining this session. Hello everyone. In this session, we will discuss a specific type of container which we can define under the pod definition, which is called init container. As the name suggests, init container is for the initialization purpose. What it means is before your application or main container comes up, if you want to initialize something, you want to run something. Suppose I want to start a backup job. I want to start a backup or maybe some kind of environment setting using a container. Then I can use the init container for that purpose. So init container will start, perform the task, perform the task and then terminate. Then only the main container will start it. So init container is having a separate life cycle. It will not keep on running it until unless init container doesn't complete its task. Main container will never start it. So that is what exactly init container rule is. Okay. So depending on your requirement, you can have more than one init container, but they will run in the sequence. So let's go and understand the things. How the init container works is okay. Okay. So what is init container? Init container are the container that should run and complete before start of the main container inside the pod. They have separate life cycle as I mentioned. Okay. Initialize and enable the separation of concern in the application. For example, you need a specific software which you want to run your application. You can do the installation as the part of init container. So this is the thing. Init container, they will run in a sequence. If I have more than one init container, first container will come, then second, then third, then only the main container will start. Main container start only once init container completed task. Due to some reason, if init containers are in the pending state, then main or application container will never start it. So it always remember init containers are need to complete their life cycle. Need to complete their life cycle means they will start, they will perform the task, and they need to terminate it. Then only the main container will start it. Init containers are exactly like regular container, except init container always run to completion. Run to completion means they will start, they will finish the task and terminate it. Each container must complete successfully before the next one started. To specify an init container for a pod, add the init container field inside the pod definition. So I'll just show you here in my YAML file how init containers looks like. Again, in my repo only, init pod.yaml is there. So AKM is same. Under the spec section, one is container and second is init containers. So what will happen? First, this init container will start it. It will pull this image. It will run this task. Once this is complete and terminated, then the main container will start it. Let's go and run this thing. kubectl create -f init pod.yaml. Okay. kubectl describe pod with init. I'll just describe it. You can see it. First, it is starting the init containers. See, pod initialization is happening, and then it terminated. So let's go and see if I'm see that how it is working. See, init container, it started it out. It pulled the image. It run this command running. Okay, so this particular thing now where you can see whether it is terminated or not. You can see it here only. Once I describe it now, you just see here that particular container which we have started it, it is completed. Okay, you just scroll it up, it is terminated and completed. So it means init container, when it is started, it will pull the image, it will run the things, whatever task has been assigned, it will do that thing, and then the main container will start it. If I have 5 init containers mentioned in this file, or 3 init containers, they will run in a sequence like this: 1, 2, 3, 4, 5, and then once it's complete, it will terminate it. I'll just show you the lab details here only in the my link. I will add this link in the uh, description of the this particular section. Okay, this particular chapter description, you can find the things. So this is the lab you will be performing it out, describe and do this thing. There is a lab number 5 is there, where you will be misspell the init container. I'm just misspelling the init container image, and then see that what is your observation. Like it should be it ideally what your observation is, you can drop me a mail, or otherwise you can put in the comment section that okay, whether it is terminated or it is spend the pending state and all these things. So we have two exercise here. First is simple. Just go and see the describe and see the life cycle of the init container. In the describe statement of the init container, when you describe it, you will see the life cycle here. So once this is completed, you should see that okay, whether it is showing you completed and terminated or not. If it is showing pending, it means the main container will never start it. So please go and check this thing and provide your inputs in the comment section. So that's it from my end for this particular chapter. What is init container, what it is use cases and all these things. So as per the use cases, you will be using it. So that is the summary for this session. Now we will go and learn the other workload API such as replication controller, replica set and deployment. Thank you for joining this session. Hello everyone. In this session, we will discuss about replication. So first, we will understand what is the meaning of replication. Replication means like if I am running an application and I need the multiple clone or copies of that particular application, how will I get it? So the replication allows you to create the multiple copies or multiple clone of the particular application. So in our case, if I am holding a pod and it's running some application container, if I want to create the replica of that pod, I will be using the replication feature of Kubernetes. Kubernetes provide the API resource for that. Kubernetes provide the API resource for that. So replication is the feature which we will be using it. So Kubernetes provide the APIs for that particular thing where the multiple replica pod will be created. We will be going to discuss about replication controller first. Then we will discuss replica set and then deployment. So first understand the replication controller. So definition of replication, I already told you, typically we want to replicate our container. That is our application for several reasons. Why we need it? We need high availability, we need load balancing, or maybe the multiple version of the same application. So that's where we need the replication feature. So replication controller is the one controller manager which is available in Kubernetes that enables us to create the multiple pods. It makes sure that number of pods already always exist. If the pod crashes, replication control replace it with the new pod. What it means is, suppose I say I need 3 replicas of particular pod, then replication controller is the part of controller manager in your Kubernetes master. So the controller manager rule is that whatever number of replica user has requested, that will be keep on running it. So if I say three replica, it means three pods must be running, must be running. If due to some reason one of the pod crashes, it will again go and restart it automatically. It will go and create it again, not restart. It will go and create it again. So that exactly the pointer here is replication controller. If it will make sure that number of pods always exist. So always exist means the current state must match with the desired state. Replication controller provide the ability to scale the number of pods, update and delete the pods from the command line. I'll just show you the YAML file which we will be referring it out. Okay, again same my repository, and you will see repc.yaml. Okay, this is our application controller. API version is v1. Kind is now, instead of giving pod, now the kind has become replication controller. Name of the replication controller under the spec section, since I told that depending on the kind, the spec section will be varying it out. So the spec section contains number of replicas. Okay, there is an important concept comes how the replication controller will know which are my replicas, which are my replica pods. So they use a concept called selector and label. Okay, so selector is the value which replication controller will be carrying it out, and it will ask the kubelet which pods are using the same label. They are my replicas. Is as simple as that. This under this template section, whatever you are seeing it, it is the definition of your pod. So what will happen is replication controller, what it will do it will see three replicas. Reading this template section, they will create the three replicas for you. Template is nothing but the pod definition. Here under the metadata section, you have the label. You have the container section is there where you have the container image is there, image pool policy is there, name of the container, and the which port has to be used it. So if I go and create this thing, kubectl create -f repc.yaml, it will create the replication controller. Okay, I'll just go and see kubectl describe replication controller. You see the replication controller is running it. Three desire and three current is running. Okay, so basic idea is three replicas are running it. So if we go and see the kubectl get pods, if I run it, three containers are starting it up. Okay, they are creating it up. So once the container is created, they will be keep on running it. You can see that, okay, this is random. Initial name is the name of the replication controller. Rest five, last five characters are auto generated. They will be provided by replication controller only. So once this is created, if I go and intentionally go and delete one of the pod, if I go and intentionally delete one of the pod, you'll find that, okay, that the ending is GF. Just go and see the get pods is again started creating it up. So it means replication controller is the part of controller manager which will be taken care, which will be take care that current state always match with the desired state. Okay. And now if I go and describe the replication controller, you can see it. Replication controller is creating the pod, and rest of the things are like three desire which is mentioned in the YAML file, three current. So always current will be matching with the desired state. How they know which are my replicas? This selector value which you are seeing it, it is a part of your master. Master will send this value to the kubelet. Kubelet will go and check the label of your pod. So if you go and run this command kubectl get pods and you just say show labels, you'll find that, okay, each of the pod is having a label. So these are the replica pods. When the selector value matches with the label. So selector is holding some key and value. It must match with the label. They are automatically marked as a replica for that particular replication controller. So these three replicas, this kubelet will be giving this information to the master that, okay, these are the label pods which is running here and they are my replicas. So selector is the value which master is carrying it up. Label is the value which kubelet is checking it out under the master. So it will look like somewhere this one. You will be having selector, like I have given app hello app. Okay, this must match with the label of your pod. Then only they will be marked at replica. Okay, if it is not matching, then this will automatically go and create a new pod for you. And that's the thing, current state will match with the desired state. Where exactly they will see the current state, seeing the label. Desired state, what is mentioned under the YAML file is populated under the etcd. So this is the first lab. You will be performing it out. I'll just show you in my documentation as well. Here, if you go here, openwriteup.com and check for the replication controller lab, the first lab, Docker Kubernetes lab session. I'll share this link in the description of this particular recording so you can check it out. So we are learning about the replication controller. So this is the replication controller YAML file, and you will be creating it from this YAML file, describing, deleting, and all this thing you will be doing it. Okay. So this is the definition of replication controller. Now, after that, we will discuss about replica set and deployment. and see that how the replication controller has replaced my replica set and deployment. Thank you for joining this session. If you have any question, feel free to ask. I have my email ID also is amit@openwriter.com. I'll mention in the description section. You can drop me a mail for any further clarification. Thank you. Hello everyone. In the last session, we have discussed about replication controller. As I mentioned, replication controller one role is because replication controller is a part of controller manager binary. So its one role is to maintain the number of replica. Then another thing is like, okay, if I'm creating three replicas, what it means is it is creating three pods, correct? So each pod is having a container image. If I want to upgrade the container image, how will I upgrade this container image? That comes under the upgrade strategy. So this upgrade strategy is also the part of replication controller only. So what Kubernetes has done it, they have break down this component in two parts. One is maintaining the number of replicas. So instead of using replication controller, you need to use replica set now. Okay, replica set rule is to maintain the number of replica, to maintain the number of replica. And there is another component is coming here, deployment. Deployment is internally calling replica set to create the replica, and then they have the something called upgrade strategy also mentioned there. Upgrade strategy is that how to upgrade this replica pod, how to upgrade this replica pod. Now question comes that, okay, I want to upgrade the replica pod. What is the problem here? See, first of all, understand the upgrade process for pod. So whenever you want to upgrade the pod container image, it is deleting the old pod and create the new pod. Create the new pod. It will not be placing the image or upgrading the image. Whenever someone says that, okay, I am going to upgrade the container image inside the pod, it means they are deleting the old pod and creating the new pod. That is called upgrade strategy. So suppose if I am creating three replicas, these three replicas is holding your application, and why you are running the replica for high availability. So you want that, okay, upgrade strategy is such a way that, okay, any given point of time the replica pod must be available, whether it is with the new image or with the old image. So that is the part of replica. So now we will discuss about replica set. So replica set whole role is to maintain the number of replica, maintain the number of replica, but no upgrade strategy is the part of replica set. Replica set doesn't contain the upgrade strategy thing. So it means is you need to use deployment for that purpose. But in the replica set, what Kubernetes has done it, they have enhanced the selector value, the selector things, they have enhanced it. Enhanced in the sense they have provided the set based selector and equity based selector. So equity based selector, you already seen it, key value thing, which I had shown you. Set based selector is something which is coming new. In the set based selector, what happens is you can provide multiple, so key can hold multiple values. So what exactly it means is, suppose there is a five replica pod, I want to create it. Replica pod, I want to create it. Or maybe your team has assigned the resources or CPU and memory for the five pod to create it, five replica pod. Already, your teammate has created two pod with different label, different selector value. Okay, or maybe you can say different label. Sorry, not selector, different label. Now you only have the scope to create the three replica only, but you ultimately your desired state will be five replica. But when it creates it, it should consider this count as well, that there are two pods are running with the old uh, two pods are already running with a different label, not old label, different label. So let's go and understand this example in clear thing. So there is a, I'll just show you. Um, this is the pod replica set pod.yaml. This is simple YAML file is there. Okay, AKMS. This is the pod only. Okay, this is the pod I'm creating it, and replica set pod.yaml. Just give me a second. Okay, replica set pod. I just remove this thing. So this pod is running it, and pod is using this label staging. So I just go and create this pod kubectl create -f replica set pod.yaml. Okay, so one pod is already running with the staging label. Now I'll just show you replica set match label, not match expression. Sorry, replica set. Oh, sorry, match expression replica set. So here, what happened? I am asking for six replica, but already one replica pod is running with this staging keyword. So ideally it should go and create the five replica only with the production label. Okay, so we have hardware resources allocated for the six replica, but I only want to run the five replica. because there is already one replica pod is running with the staging label. Okay, so let's go and do this thing. Kubectl create hyphen f match expression. Okay, the replica set get pods. I'll just show you. See here, how many pods are creating? One, two, three, four, five. Because there is already one pod is running here. I just show you get pods hyphen hyphen show hyphen labels. So here you can see it. One replica is running with match staging, environment staging. Other five is running with the production. So total six replicas are running. But when it goes and when the replica set controller goes and start creating the replica, it will first check the label. If already one pod is running with the other label, and so it will only create the five pods. So that is considered in the count itself. Okay, I'll just show you here kubectl describe replica set. Okay, here also you can see it is only creating the five pods. So this is the example where you can use the match expression, and that is the one more enhancement on the selector side. Kubernetes has done it. So if I show you here how it is there, selector, you are putting match expression, key is one, operator in, and you are providing multiple values. So environment either can be a production or staging. Inside the label section, if it is production also, it will mark as my replica, or if it is staging also, it is mark my replica. That's the reason when I started one old pod with the staging label, it is marked as a replica, and that's the reason replica set is creating only the five replica, because already one replica is running with the different label. That is a reason we use match expression here. Now I'll show you the lab part. This is the match label one. Is similar like replica set only. The one which I have explained you match expression one. In the match expression one, what I'm doing it here is I'm creating match expression five or six replicas, and then I'm trying to create the pod with the different same label. It will not allow to create it. Okay. Now if I go and do the reverse way, I deleted the replica set. Now I just did the same thing. I have just first created the pod, then I try to create the replica set. Since one pod is already running, it will run whatever is like six replica is there. So it will only create the five replica because one replica pod is already running there. So this is exactly where you will use the match expression. This is one of the use case. There are multiple use cases there where you can use the match expression when you want to match the label. You are having multiple label with the different values. So selector can go and pick all the labels which is provided there. Hope this is well clear to you. This is the lab which you need to perform it. This is lab number 2, which you will be performing in this link. And let me know your feedback about the topic. Thank you. Thank you for joining this session. Hello, everyone. As I mentioned initially that the replication controller is replaced by replica set plus deployment. Replica set is whole role is to maintain the number of replicas. So if I say I need three replicas, the replica set controller will take care of that three replicas any given point of time is running it. Deployment is taking care of the update strategy. So how to upgrade the container image, okay, that is taken care by deployment. So deployment is another API resource in Kubernetes. Okay, it's another type of API resource in Kubernetes. If you go and run this command kubectl get mm, this thing kubectl, just give me a second. If you run the command kubectl API-resources and grep for deployment, you will find that okay, deployment is another API resources there. Kind is deployment, D is capital here. F's v1 is there. This is a name resource is there. So this is the API version. Now deployment is having it. What deployment will do is in the deployment.yaml file, in the YAML file of deployment, we will be mentioning how many replicas we needed. Deployment will internally call the replica set, or otherwise I say deployment will internally create the replica set, and replica set will take care of the replication part, and deployment will be having the upgrade strategy. So let's go and see the YAML file. Okay, here you can see it. API version, kind is deployment, metadata, name of the deployment. This particular thing is creating in the particular namespace. How many replicas I needed? Five replicas. This is the label selector, and this is the label definition. So five replicas pod will be created. Okay. So first of all, what deployment will do it? Deployment will go and create a replica set internally. In this whole thing, you are not seeing any kind of update strategy is there. Update strategy is the part of deployment only. But if I don't mention any update strategy, it will be by default always rolling update. Two type of native update strategies are available there. Native update strategies are there. One is called rolling update, and second is called recreate. We will discuss in detail what is rolling update, what is recreate. Currently, update strategy is by default there. Let's go and run the deployment kubectl create -f dev.yaml. This deployment will be created inside the dev namespace. So I'll just show say kubectl describe deployment, okay, nginx-deployment. If I run this way, it will fail because I have not mentioned the namespace here. Okay, if I run this way, it says not found. I need to mention the namespace equal to dev. Inside this particular namespace, you'll see first deployment has created a replica set. This replica set is creating the replica. Another part which you should observe it is the strategy type. Since I have not mentioned in the YAML file which strategy I want to use it, it is by default rolling update. Rolling update strategy has two parameters. One is called max unavailable and second is called max search, which we will discuss in the upcoming session. Currently, you should observe it. It is created kubectl get deployment. If I go and run it, you'll find this thing get deployment hyphen namespace equal to dev. If I do it, you'll see that okay, it is created a deployment. And similarly, if I go and see the replica set, deployment only has created the replica set. So deployment is taking care of all the things. Deployment internally called the replica set. Replica set creates the replica pod, and deployment will take care of the upgrade strategy using the replica set. Clear? So you guys will be performing the lab which is mentioned in this documentation. This is the lab which you will be performing it out. This is lab number 3 which you will be performing it out. There is a dev.yaml file is there. You will go and get the deployment, get the pod, describe the deployment, see that whether in the deployment which controller is used. So here in the describe event, if you see it here, you will find that okay, deployment.controller is there, but internally it is calling the replica set. Using the replica set, you see read this message, scaled up replica set. This is the replica set 2.5. So basically deployment is only calling the replica set API to create the number of replica. And second part which you should observe in the describe statement is the upgrade strategy type. So if I have not in the YAML file, I have not mentioned anywhere which upgrade strategy I am using it. Update strategy I am using it. So if it didn't mention it, it is rolling update always. So by default, it is rolling update. Thank you for joining this session. And let's connect to the next session. Hello everyone. In this session, we will discuss about rolling update. What is rolling update upgrade strategy is. So first of all, suppose understand this thing that if I have mentioned three replicas under the deployment, what it does it will create a replica set, and on that replica set will create the three replica pod. Okay, these three replica pod will be holding some image like app version v1 is running there. Now I want to upgrade this image to app version v1 to app version v2. First of all, in Kubernetes, whenever you say that update the image means update the pod image means delete the old pod, delete the old pod and recreate new one, create the new one. Okay, new pod. So there is a downtime for that particular pod image. Now if I'm running three replicas and I'm using rolling their update strategy, in the rolling update strategy we are seeing two parameters. One is called max search and second is called max unavailable. So what this parameter does it, if I mention three replicas and I mention 25% here for max search and 25% for here for max unavailable, what it means is during the upgrade process, when you're going to upgrade the things, how many pods you can extra pod you can add it, extra pod you can add, and remove or remove. Okay, so what it means is 25% is 0.75. So basically one extra pod you can add it and one pod you can remove it. So during the upgrade process, my pod count, running pod count can be 2 to 4. This between this range, my running pod count will be coming it. So max, it's not necessary you provide the percentage. You can provide the absolute number as well. I can put one as well. So one extra pod I can add it during the upgrade process, and one extra pod one pod I can remove it during the upgrade process. That is what exactly is about rolling update. Now go and see the YAML file. If I don't mention anything, it is always rolling update. If you want to mention the strategy type, you can mention rolling update. Max surge is 1, 25%, number of replica 3. So when I go and replace this image with the latest image, what will happen is it will go and start the upgrade process. And in during the upgrade process, what will do it? Currently, for deployment, what it will do it? First time when I create the deployment, let's go line by line. I'll just go and create the deployment, create -f ru.yaml. Okay, I just create the deployment and say describe the deployment. Okay, I just go and describe the deployment. Hello, RCP. You see, deployment has created a replica set. This replica set is running this image. Okay, three replica pod is created. You can see the last two character F9. F9 is running three pods. okay, with this particular image. Now what I will do is I will go and upgrade this image or replace this image with the new image. Okay, let's go to my lab documentation and see how I can do this thing. Okay, so here I'll go in my lab documentation. There is a command is available there. Set image command is there. In the set image command, I'm just replacing this image with this particular image, nginx image, with the new image. Once I run this particular command, what it will do, it will update the image. Now if I go and describe my container image, okay, you see, 1 second, I'll just go and describe my container image. Okay, you can see it. Now what is happening? First of all, deployment is created a new replica. Older one was having F9. Now last two character is 57. The 57 one is creating new pod. First it has gone. It has, first of all, it has gone, created a new replica set. This new replica set has created one pod with this particular image. Okay, so currently total how many pods are running here during this time frame? Four pods are running. Three pods are running older image, one pod is running new image. So total four pods are running. Why it is allowed? Because my max search parameter is allowed to add one more extra pod. What is my desired state? My desired state is three replica, but currently how many replicas are running? During this message, when it is printed it out, four replicas are running. Now what it has done, it has scaled down F9 replica to 2 from 3. So again, it has become 3. Now again, I'll go and describe it slowly and gradually. The new replica 57 is 3 and the old replica has become 0. So complete image upgrade has done using this thing, using rolling update. So during the rolling update, new pods are added using the new replica set and old pods are you can say scaled down or removed using the old replica set. So, but during this whole process, you allowed to add any new extra pod using the max search parameter. So this max search parameters allow you to add the extra pods and allow you to remove the pods during the update process. So current state can be vary during the update process. That is happening due to the rolling update. But one thing you should observe it during the rolling update strategy, I'm not adding, I'm not what to say, I'm not getting any application downtime. Whole the time my application was available. Important part is observe this, describe, try to understand this particular section where the event is happening. Just see old replica set, new replica set ID, and old replica set ID. This is the new and this is the old, and see that how the scale up and scale down is happening. If you read this message, you will clearly understand how the max search parameter is playing a role and allowing you to add the extra pod and removing the old pods as well using the max unavailable parameters. So these are the things which you should see it. Left side, you guys will be performing lot of commands are available there, such as rollout status command is there, rollout history command is there. I can go and see how many revisions are created there. So all these things are available. You can go and check it out. Say two revisions are there. First revision will be having older image second, so I can go and revert it back. I can scale up the number of replicas. So these all commands are available in the deployment. So these all commands are documented. Please try these commands. In case you face any issue, feel free to drop a mail to me, amit@openwriter.com. Thank you for joining this session, and let's connect to the next session. Hello everyone. In this session, we will discuss about another update strategy that is called recreate. See, in rolling update, what is happening is, suppose if say I have 100 replicas. Okay, so basically 100 replicas means 100 pods it will create it. And the max search parameter, if I set to 25% of 100. So it's basically 125 replica, maximum 125 pods it can create it. For running the 125 pods, I need that much CPU and memory must be available in my system. So if you are using rolling update strategy, you must be taken care that particular part that okay hardware resources are available in case of rolling update strategy. Then the another update strategy comes in the picture, which is called recreate. In the recreate update strategy, three replicas suppose has been created with the app version v1 image. Suppose the image name is app version v1. Now I replace the image to app version v2. First recreate strategy, what it will do, it will go and delete the old replica set, delete the old replica set and create the new replica set. Create new replica set. So what will happen if we delete the old replica set? All the old pods will be deleted. All the old pods which is running app version v1 will be deleted. Will be deleted. All the new pods will be created with the new version which is app version v2. So it means there is a application downtime will be there because the old pods are deleted. So there is no one is there to address your issue. Okay, so there is no application pod is running there. All the old pods are deleted, and when during the creation time, the new pods will come. So it will take some time. So there is a downtime will be available for that. And that's the reason recreate strategy mostly will be used where you have proper maintenance window, or maybe you are using in the QA or dev environment. So recreate strategy will be used there. I'll show you the YAML file. This is the YAML file. The type is recreate. What I am using it, 3 pods I am running it. So what will happen? First, while creating, it will not make any difference because create -f rc.yaml, I do it. It is created the deployment. Okay, I just describe the thing. Describe deployment. Hello RC. I just go and describe hello RC. Sorry. I just go and describe the deployment. Hello RC, RCP or RC. One second. Uh, kubectl get deployment. Okay, this is hello RC. Where exactly this has been created? Oh, this is created in the dev namespace. Sorry, my bad. Get deployment namespace equal to dev. Okay, here you will see that hello RC is created here and namespace equal to dev. Okay, so in the dev namespace, if you go and check it out, see this is running new replica set, and this is the version it is running it. Okay, now I go and change the edit the deployment and change the image form. You can use set image command as well, or otherwise edit deployment command also you can use it. I'll just go and change the version from v1 to v2. So this image is already available, guys. I have already created it, so that's the reason it is available on my Docker registry account. So I just go and do this thing. Now I describe it. You see, first old replica set, this is the F9, it has gone to 0, and then there is a new replica set is created. So there is a application downtime is happening when you are using the recreate strategy. So to summarize this session, recreate strategy you will be using in the QA or dev environment, or maybe when you are having a proper maintenance window where application can go for the down time. Application means the application, this application can go for the down. Okay, so there is a downtime, planned downtime is there, then you can use the recreate strategy. Recreate strategy benefit is you don't need any extra hardware resources. In the rolling update, you need to go and put the calculation that how many extra CPU and memory is needed, because max search parameter, you will be adding extra pods. Suppose I have 3 replicas, but max size parameter allow me to run the 4 replicas. So I need to plan that how the fourth pod will get the CPU and memory. So recreate strategy will not require any new hardware resources. You can go and run the recreate strategy with the existing hardware. Thank you for joining this session. Let's connect to the next session and we will discuss the daemon set and jobs. Hello everyone. In this session, we are going to discuss about Kubernetes, one more microservice APIs. Okay, Kubernetes APIs, which is services. Okay, first we will understand why services are required. Okay, so we will go through the lab scenario which we have done it in the previous session, where I have launched the replicas using deployment. When I have launched the replica using deployment, you can see it, 5 pods are running it. Okay, each pod is having a different IP. Each pod has its own pod name. When I'm launching through deployment, each replica pod is getting its own name, which is randomly generated, followed by the IP. Now here, what is the point you should note it out down is that the pod name, when we are using deployment, and the replica pod which is created, the name and IP of the pod is not static. They will change when the rescheduling happens. Okay, I'll just show you here. I'll go and delete this pod, delete pod, and this pod I will go and delete it out. And when it will be created, it ending it with the RVD. Let's go and see it again. There is a pod 4 seconds before it has created. You can see the pod IP is also changed, and the name of the pod is also changed it out. So this is the problem. So suppose you have two different set of application is there. One application is front end, which is running 3 replica pods. Okay, and each 3 replica pods has different IPs. Second is backend, which is running your DB kind of application or some kind of application which has to be connected. Front end wants to communicate to the backend. Now the IP or the name of the pod is not static. IP can also change or name also can change it. So in case of rescheduling, if the new pod is rescheduled, how the front end will know which are my backend pod, or even vice versa, how backend will know which are my front end pod, because pods by nature are stateless. Stateless means the IP and the name both are not static. Replicas will be, once it deleted or rescheduled, the name and the IP will change. Okay, so how the two application will communicate to each other, or even I'm hosting some application in the pod format, or some outside world application want to reach it out, how they will reach it out, because the IP can change. How will they know where to communicate it? Okay, so here only Kubernetes launch one kind of API resource which is called services. Let's go and discuss about Kubernetes services, what exactly it is, and how it is going to help you out to address this kind of scenario. So Kubernetes services is an abstract way to expose an application running on set of pods as a network service. Kubernetes pods are created and destroyed to match the desired state, correct? Pods are non-permanent. Some pods called backend provides the functionality to other pods to do front end inside your cluster, how the front end will track or keep the IP address or how they will connect it. So here only the first resource type which is going to address it here is service resource. In Kubernetes, a service is an abstraction which provide a logical set of pods, a policy by which to access them. Sometimes it's called microservice. A set of pods targeted by the service is usually determined by the selector. So here what exactly is going to happen is you can visualize this thing in this way that okay, if I am running a application multiple replicas, I will be a single application without containerization or without pod. Simply a application multiple copies are running it. We use a load balancer concept. Okay, through the load balancer, the traffic will be forwarded here. Similarly, now what exactly is going to happen? There is a service type resource will be created. This service type resource will be finding it out which are my pods where the traffic has to be forwarded. Okay, this service will be having a name as well as followed by the IP address. So this is a kind of a virtual IP address which is internal to the Kubernetes cluster. By default, service has multiple different types. Initially, that if I don't mention the type of the service, it is always a cluster type service which will be created. The IP which service is going to provide is the internal IP. So the pod can communicate to the service, and the service through it will go to the respective pods, okay, which is the endpoint. Here we will be using one more term called endpoints. Endpoints are nothing but the IP address of your pod. Okay, so we will be forwarding your traffic to your pods. Okay, now here you can see it. I'm running 5 replicas here. Okay, so this is my 5 replica. I just show you get pods hyphen show labels. So 5 pods are running it. Each pod has the replica label app nginx. Okay, now what I will do it, I will go and create the service type resource. I'll just go through service type resource. This is the name of the service. Okay, this is sorry, this is a kind of the service. This is the name of the service. Currently, I'm running in the default namespace. I will remove the namespace. App colon I need to give nginx. Okay, here you can see it. I have not mentioned the type of the service, so it is by default cluster IP type of service. The port where service will be listening, target port, the port where container would be listening. Basically, in the pod, you're running a container, and that container will be running some kind of application. So, where exactly that application will be listening, that is the target port. Now, I'll go and create the service. First, I'll show you the service. Okay, I'll go and delete all the services so confusion will be not there. I'll just go and delete the old services which I have created it. So, I'll just go and create it now. Create. Mostly services I deleted it out. Okay, now what I will do is I'll go and create the service type resource kubectl create hyphen h svc dot yaml. I'll just moment I create it, you'll see that okay, there is a service type resource is created. I'll just run the command kubectl get svc, and you will see that okay, service type resource is created. Type is cluster IP. There is a name is created. Service is listening on port 80 8 seconds before it is created. Now I told one more thing that service will be mapping to your pod IP address. So here there is one more command comes kubectl get EP. EP stand for endpoint. Here will be the name of the service, and these are the IP address of your pod. These are the IP address of your pod. How will you see it? Your IP address. You will run the command kubectl get pod hyphen oy. You will see 204, 205, 207. So all are the IP address of your pod. So how the scenario will look like now? You will be forwarding the traffic to your service. Okay, through the service, it is going to the pod pod IP address. So service is just a logical entity which is sitting in between to send the traffic. In case a pod is added or deleted, automatically service will find it out that which are the newly added pod or which are removed. This whole process is called service discovery. What is service discovery? A service discovery is a process where service uh, and controllers will be running using the selector. They will be finding it out which are the pods are having the same label and automatically update the endpoint table. They will keep on adding the endpoint table. So here you can see it. This is my endpoint table. Currently, this endpoint table is showing 5 replicas, which you can see it. I can go and edit my deployment. I'll just go and edit my deployment, get deploy, kubectl, edit deployment. I just do it. okay, and show you that if I go and remove the replicas, how what will happen. So I just go and remove the replica. Currently it is 5. I'll make it 2. Automatically endpoint table will be updated. You see it's showing 2 only. So this is the concept of service discovery. Again, I will repeat, service discovery is a process where service controller, which is the part of Kubernetes API controller manager, which will go and use the selector value, which is under the SVC service.yaml file, and run the scan on the worker node and find which pods are running with the same label. So the pod level, if it matches, automatically service will go and update the endpoint table. Okay, that this table will be updated automatically, and this process is keep on running process. So automatically this will be running it. So couple of topics we learn in this topic, in this chapter. First, why services are required, what services are doing it, what is the default type of services, what is service discovery process. I will be adding the lab session here as well end of the session. Thanks for joining, and let's connect to the next session where we will discuss more detailing about the services, what is node port type service, what is load balancer type service, everything. Thank you. Hello everyone. Today's session we will be performing the lab on Kubernetes service type resources. So in this session, in this lab session, first we will be creating a deployment. So I'll just show you my deployment.yaml file, what it contains it. So you see my deployment.yaml file, the important part is this label. As in the previous theoretical session, I explained you, service discovery is the process where service will go and discover the pod as the pod IP address and update the endpoint table. So we will see all these things. So this is the label which we will be looking at. So when I will run this deployment, or I will run the kubectl create command for that, it will be going to create the 3 pods. Okay, and all the 3 pods will be running this nginx container. Let's go and do this thing. Kubectl create -app dev.yaml. I will be sharing this YAML file with you. So you'll say get pods. If you run it -o wide will show you all the 3 containers will be creating, and once the 3 containers are created, you'll see the 3 IP address will be visible here. Okay. Once this is done, we will be creating the service.yaml. In the service.yaml, first deployment.yaml, just go and see it out. What is the label you provided? App colon nginx. So in the service.yaml, the selector value will be app colon nginx. Okay. This must match with the label of your pod. And currently we have not mentioned what type of service it should create it. So by default, it will create cluster type. Okay, cluster type service will be created. Let's go and run this thing. And by let's go and see first that output. So I told 3 pods will be created. These are the 3 IP address which pod has got it. Okay. Now I'll go and create the service type resource kubectl. First I'll show you service. There is no service. Okay, there are 2 3 services are there. Let me delete all this services, so our setup will be cleaned. Okay, just give me a second, I'll delete it. Kubectl delete svc and this one. Okay, both the services are getting deleted. Now I'll go and use kubectl create -f svc.yaml. Okay, service is created, kubectl get svc. This is the IP address which service is getting it. This is where port service is listening it. There is no external IP. It means service type cluster IP type service will be internal to the Kubernetes cluster. Now I told there is an endpoint table will be created. So you run the command kubectl get EP. EP means endpoints. You'll see the service name is there and 3 IPs are there. 223, 224, 225. If I go and show you kubectl get pods -o wide, you'll see these IP address are the IP address of my pods only. Okay. So how the things are working, this service, you will be forwarding the traffic to this service. From this service, the traffic will be going to this IP address, which is the pod. Internally, your application container is running it, which will be responding you in the round robin mechanism. So in this whole scenario, we have used couple of command. I will be sharing with the documentation and the YAML file. You guys have to first go and create the deployment.yaml, check the label there, then create a service and see the endpoint table. So all these things I will be sharing it, and please perform this lab and provide your feedback. Thank you. Thanks for joining this session. Welcome back. In this session, we are going to discuss service type called node port. Okay. So each of your Kubernetes is having a group of host, which is called nodes. Okay. So these are called nodes. Where exactly worker nodes? Nodes means worker nodes, where you are running your container. So these are the small thing which is called container. Now, if I want to go to the outside world, this container applications, if someone wants to use it or access it from the outside world, they can use the node port to access it. Cluster IP type service, which we have seen in the previous session, they will not be accessible to outside world. Their cluster IP type service scope is limited to Kubernetes cluster only. You cannot go and communicate to the outside world. To communicate to the outside world, the easiest way is using the node port. Okay, so node port is this nodes which is there. This worker nodes are there. Using this worker nodes ports, we can go and communicate to the outside world. There is a range 30,000 to 32,767. That is the range which is blocked for that. You guys can use for that. Okay. In the YAML file, nothing has to be modified much. It's just the type of the service will be the node port. Okay. I'll just show you node port service type cat node port YAML. Here you can see it. The type of the service will, okay, this is the range which I told you. Okay. And this is the service type. That is a node port. So the moment I mention this service type as a node port, the port number will be blocked. If you have three cluster node, okay, three worker nodes are there, all the three worker node, the particular port will be blocked. So same example, we will be performing it, which I have done it in previous. I'll just go and delete the old services if they are, okay. Now what I will do it, I will be creating it node port. Okay. So first of all, let's go and see the dev.yaml. What is the label for the pods? Okay, this is a label for the pods. Now what I will do it, I will go here and modify my YAML file and provide the same selector. Okay, when the selector matches to the label, automatically node will be through the node port we can access the application. Okay, I'll just go and create the create hyphen f node port.yaml, and now I show you the service kubectl get svc. You will be seeing it, there is a node port is coming, that is 30,007. So my machine IP address, if 30,007 I will give it, the service or the application must be available to you. So I'll just give here cubes here, give the IP address and give the port number 30,007. See, application is available here. Okay, so this is the way you will be using it. Okay, I'll just show you get EP and you'll see all the three pods are available. In case if I go and delete the pod, okay, delete all the deployment pods. Okay, and now see, now there is no endpoint will be available, even service is available, but if I go and try to open it now, okay, if I go and try to open it, it will not open it immediately. Okay, it will be giving a error message to me, page not found or something like that. So service is just a abstraction. Ultimately, the application which is running inside the pod, that is what exactly is going to respond to you. If that particular field in the get ep table, if you're finding none, it means service is not forwarding, or there is no, a pod has been identified by the service where they need to forward your traffic. So it means there is no application has not mapped here. So any type service you are using it, if service discovery is not finding the pod or endpoint table is not updated with the pod IP address, it means service, even the service is still there and service IP is still there, service will not respond you. Okay. So these commands I will be sharing with you and with the YAML file and other things. Please perform the lab. Lab, how will you perform it? This is a web link. I will be sharing it here. This is the second lab which we will performing it, node port, as you can see it, and you will be creating this whole example here. Okay, and perform this lab. This is lab number 2. Further labs, like they have many other different type of services such as headless and uh, service without selector or load balancer. We will see. I will be releasing soon in the advanced session. Currently, this uh, training, the objective is that we should create a application or three-tier application using the node port or service and show you. So in this particular section, I will be covering till this point only. Later sections, I will be coming up with the other service type of services and little service mesh and ingress and other things. Thank you for joining the session. Thanks everyone. Hello everyone. Till now, we have discussed about workload APIs, where we have discussed what is pod, deployment, replication controller, replica set. But in the workload API, ultimately we were creating the pods, and inside the pod, the container was running it. Then we have discussed about networking API, where we have seen that how to configure the network if I have multiple replica pods are running it, how to create the virtual services or virtual load balancer for them to reach that, how to expose the service containerized application to outside world, that is through network APIs. Okay, now coming that, okay, each of your pod is running a container. Inside the container some application is there. If the pod gets deleted due to some reason, if the pod gets deleted, definitely pod is not accessible, pod get deleted, I will lose my data as well. To safeguard my data, we have two types of API which Kubernetes provided. One is called PV, second is called PVC. What is PV? PV stand for persistent volume. PVC stand for persistent volume claim. Now question comes, how, where, which one will be using it? So first of all, PV is the piece of storage. You can visualize the PV as the external hard drive, okay, where your real data will be residing it. Okay, so whenever a container wants to containerize application in Kubernetes, want to store the data, there will be a PV for that. Depending on our situation, the PV will be either automatically created or we will be manually creating it. Okay, so what is PV? PV is a subsystem, provides an API for user and administrator that abstracts how storage is provided and from where it is consumed. Okay, so PV is a piece of storage, as you can see it in the cluster, that has been provisioned by the administrator or dynamically provisioned. Okay, so it is similar like how the node is a part of cluster, same way PV is a part of storage. Then second definition of what is PVC then. See, whenever a user wants to consume the storage, they need to claim it. And that is what exactly PVC is. PVC is a request for the storage by a user. It is similar like a pod. When the pod requests a resource, node provides the resource. Similarly, PVC will request the resource. PV will provide the space to them. So when pod runs, it requests for CPU and memory to the node. Similarly, PVC will request the storage space. Okay, depend on access mode and size and other things. Two type of provisioning works. One is static, one is dynamic. In this session, currently we will understand static. Later on, I will be adding the videos after the project, that depending on the feedback and other things, I will be explaining the dynamic provisioning lab. I will be also providing it. For explanation purpose, I will be covering it now. Later on, I will provide the lab for that. Reclaim type, two types of reclaims are there, retain and delete. Retain means if the application get deleted, still the data should be retained, or if application get deleted, data should delete. Okay, these are two types are there. Now see how it looks like. This is your storage. You will be mapping PV. PVC will claim PV and map to the application. So first, if I'm talking about static provisioning, you guys will be creating the PV. You will be mentioning from where and the size of the PV as well. Size of the PV as well. From where means for which location you want to map it, and the size of the PV will be also mapping it out. So first you will create the PV type resources. Then you will be creating the PVC type resources. In the PVC type resource, you will mention what size you need it. Okay, what access mode you need it, and what is the storage class. Storage class is quality of services. Like I want some specific storage class, you can mention that should be available in your system. Using that, they can claim it. Okay, so main thing is, if I'm writing PV first and creating PV first and blocking the storage, reserving the storage first, and then PVC will request this PV, then it is called static provisioning. Here you can see the diagram as well. Step number one, I am creating PV. Step number two, this is mapped from here. Step number three, PVC is claiming the PV. Okay, PVC is submitting the request. If everything is matching as per the request, PVC will be able to map the PV. Okay, this exactly is the scenario. We will be going to try it out. Okay, I'll show you both the YAML file and then we will discuss in detail how the YAML has been designed. Okay, so this is the pv.yaml. You can see it here. The type is persistent volume. PV, this is the name. Label is for the filtering purpose for now. Currently, this label is nowhere related to what label and selector we have seen in deployment and services. This is just for the currently, if I have many PV created and I want to, through the command, I want to filter it out, I can use this label. Important part is this storage class. Currently, I don't have any storage class created, so it is mentioned manual. What is the size I'm mentioning? 10 GB. Okay, what is the access mode? Read write once. And which location? So currently it is host path. Host path means wherever the pod will start, in that particular pod worker node, this path will be providing this 10 GB space. Okay, that is what exactly how the PV will be mapping the storage from this location where the pod will start, whichever worker node. So from there, that location will be mapped as a persistent volume. So first you guys will be creating the PV, then you will be writing the pvc.yaml. In the pvc.yaml, you can see the storage class is manual, access mode is read write only once, sorry, and the size. These three things will be there. Automatically it will go and bound at PV. Okay, I'll just go and create the PV first. I'll show you kubectl get PV. Okay, there is another PV there, but I create -f pv.yaml. I create the PV. PV is created. I'll show you kubectl get PV. You can see the PV is available. PV is available. It is not bounded anywhere. So it means PV is available. The moment I will create the PVC based on my request size, based on my access mode and storage class, automatically it will bound it. If the two of the PV is satisfying my request, then it will go alphabetically or ordinal order. Whatever PV will come in upper in the layer, upper in the finding, they will automatically bind that one. Can I mention the PV name in the pvc.yaml? Answer is no. You cannot mention it. Okay. So I'll just go and click create hyphen app pvc.yaml. Okay. Now you say that kubectl get PV. You'll see that it's bounded here. But can I go and use it directly now? Answer is no. You need to go here and create the pod.yaml file. Inside the pod.yaml file, one more section is coming under the spec, that is volume section. Under the volume section, I am mentioning the claim name. So the claim which I have created it here, correct? The claim which I have created here, kubectl get PVC. This claim name I'm mentioning it here inside my pod YAML file. Okay, so this YAML file is there. This is the claim name I have mentioned it here. What exactly it will do it? You can see there is a under spec volume section. There is a name of the volume is coming. This name is defined by you only. You can use any name here. Only thing which should be matched here is the claim name which you have created it already. This claim will match to this, and where.www.html will automatically use this claim path. So in the claim path, what we are claiming? MNT data. So let's go and see it. I'll just go and create the pod kubectl create hyphen f pvpod.yaml. So pod, once it is created, let it creates. I'll show you that particular path, how it will look like in our lab documentation. So lab documentation, I will be providing this lab documentation to you. So you guys can go and check it out. The lab number 13, which is PVPVC. So I have done the first part, second part. Now, once the pod get started, the pod is running. I can go and describe the pod, kubectl describe pod, my pod. I think the name is my pod. You can see it here. The persistent volume claim is coming here. Okay. I go inside the pod and show you. I'll use the command kubectl exit command to go inside the pod. I'm inside the pod only. Now, if I write something under this location, cd where www.html, I'll go and write some file here, touch new file. Okay, I just create this thing. I come out from the pod and show you MNT data location. You'll be able to see this thing. Okay, so this is the persistency. Even though my pod gets deleted, I'll go and delete my pod, delete hyphen f pvpod.yaml. Sorry, cd. I'll go and delete my pod kubectl delete hyphen f my pod.yaml pvpod.yaml, and I just go and recreate it again. Still my data will be available to myself. Okay, let's go and create it and see. Once the container is created, now I'll go and run the command exec. Inside the pod, if you go cd where www.html. So by default, PV will be always going to retain your data until unless you will not mark as delete. Okay. Last part of this is how to create a dynamic provisioning. What is the meaning of dynamic provisioning? In the case of dynamic provisioning, what will happen? You need a storage provisioner. As you can see in the diagram here, if I have the dynamic provisioning, the storage provisioners is required here. Storage provisioners are something which vendors provided. You can visualize storage provisioners is the plugins which all the storage provider provided. Okay, so you will be only creating the PVC. PVC request will be submitted to the storage provisioner. Storage provisioner will see the request size, what is the size you requested, and automatically create the PV. So in the dynamic provisioning, user or administrator will not create the PV. PV will be created by the provisioners. So your request will go to the storage provisioner. Through the storage provisioner, it will be going to the storage and target, and they will create the same size what has been requested and map it here. That is called dynamic provisioning. So in current project, which I am going to cover it, we will be only discussing PVC part. Later on, once I will get the feedback from you guys, I will be adding the dynamic provisioning here. You guys can drop a mail amit@openwriteup.com if you want to see the dynamic provisioning. I will definitely adding it there. Thank you everyone. Thanks for the joining the session. Okay. Hello everyone. In this session, we are going to discuss about config map. So we have seen workload APIs, storage APIs, networking APIs. Now we will see some of the config APIs where the running container, if I want to pass some kind of non-sensitive data or sensitive data, when the containers, when the pod are spinning up, how can I pass it? Okay. So rather than putting the hard-coded values inside the container image, we will be passing these inputs using config map. So first of all, we will see the definition of config map. So definition of config map says a config map is a storage space, is an API object to store the non-confidential data. Okay, non-confidential data means non-sensitive data. Suppose my container, when it is coming up, it looks some kind of config files, or maybe some kind of input values, which is like a number of counts, or maybe username, or maybe not username, basically user details. Okay, metadata information like that. The all must be, when I say username, also it is a non-confidential data. The confidential data is just such as password, secrets, token, they are confidential data. That is a separate topic. We will discuss it. So config map is an API object to store non-confidential data. Pods can consume this config map as an environmental variable or as a volume. Okay. So we can map it. Config map, no encryption will be there. Okay. You can hold up to 1 MB data. So this is the config map YAML file. I'll show you here. First, you will be writing the config map YAML file. So this is the YAML file. Here you can see the kind is config map, name of the config map. Now spec section is not there. Either this section will be data section is there. Inside the data section, you are providing the key and value. This key is already must be used by your application. This is the key field. This is the value field. This is the key field. This is the value field. Second section, which you are seeing it, it is called file like keys. What is the meaning of file like keys? You will be having multiple keys and values are available under a single file. Like properties file is there, config file is there. All these things will be coming here. Okay. So the data field contains what inputs I want to provide it when the pod will go and spin up the container. Okay. So this is the thing which you will be creating it. I'll just go and create the config map using the keepctl command, and the config map is created. Now how to use in the pod? Okay, inside the pod, how will be using the config map? So the cmpod.yaml, you see it here. Spec section, just scroll it down and you will be seeing there is a volume section is coming. If you remember, when we were using the PVC, we have used this section, but in that we were giving the PVC claim PVC name, but here we are giving the config map. We are just mentioning the config map, and the name of the config map will come here. Volume name, again same thing. Volume name is defined by you. This should match with the under the container, whatever volume mount name is coming, they must match. Okay. Now the last part is the last part is how it should go. Okay, if I'm using the volume and volume mounts thing, the item, this is the key name which is mentioned in the config map. Under the mount path is that what will be the file name, that is what exactly is the thing will come. Okay, under the mount path, under the config, there should must be a game.properties or user interface.properties file must be created. So this is one way to map the config map inside your container. Second way is you can use environmental variable. Inside the environmental variable, you can map value from the config map. Key reference will come here, and you will be providing the name and the key field. Okay, so that is key based config map mapping. I'll go and perform the lab and show you how you can use the config map section and define the things for yourself. Okay, just give me a second. I'll open my lab and share you. Okay, this is the lab. Okay, just give me a second. Okay, now this is the lab which we will be performing it. I already created the config map. You can go and describe it. Already now we will create the pod. Okay, inside the pod we will go and see whether the config map is. So this is the YAML file which I will be provided in the lab documentation. You just go and create the config map. Now describe the config map. You will be able to see it. There is a config map is already mapped there. Okay, once the container will come up here, you can see the config map is already there. Okay, I'll just see kubectl get pods. So want to confirm it that the pods are running. Okay, pods are running. Now using the exit command, I will go inside the container. I'll go here. I'm inside the container. I run the command export, and you will be able to see it here. The config map is shown. This is the thing, key value based. This is the key value based. Second thing, I should see it. The config directory must be created. Inside that, game.properties or user interface.properties should be created. The game.properties is also there. The user interface.properties is also there. Now, if I go and modify the config map, will this value will be reflected here in the runtime of the container? Answer is no. If the containers are running and you go and modify the config map YAML file and apply it, it will not on during the runtime or while the container is running it, they will not able to pick the value. Okay. So for that, you need to go and delete the pod and recreate it again if you want to reinitiate your config map. So config map, just want to summarize the thing. Config map is used for non-sensitive data. If I want to provide some kind of counters, some kind of properties file or config files, which is carrying non-sensitive data, we can use config map. Config map size cannot go beyond 1 MB. No encryption will be provided on the config map. And you can use two ways to map in the pod. One is using volume and volume mount, and second is as an environmental variable. I will be sharing the lab link in the chat in the documentation. Please perform the lab. Any issues, please drop me a mail, amit@openwriteup.com. Thank you. Thanks for joining the session. Hello everyone. In this section, we are going to discuss about if my container application is running some kind of sensitive application, some kind of application which require some kind of sensitive data, how will I pass it? I can use a API resource which is available in Kubernetes called secret. Whenever I want to pass the sensitive data, secret is the best way to do it. Secret can take the secret, which is type of username password as well. It can take its secret tokens. It can take it TLS certificate, SSL, all these things, Docker registry credentials, all these things secret can go and provide to the container application. The main difference between secret and config map is used for non-sensitive data. Secrets will be used for the sensitive data. Okay, we will be seeing it as a couple of example for the secret. Okay, so what is first of all the definition? A secret is an object that contains a small amount of sensitive data, such as password, token, or key. Secret, how can you map to the pod or inside the container? You can use volume and volume mount, which we have used in config map, or you can use the environmental variable as well. You can specify data or string data when creating a configuration for the secret. So again, same thing, API version kind metadata is there, but there is no spec section will be there in the YAML file. It is either data or string data will be there. Individual secrets cannot go beyond 1 MB size. Okay, so secrets has different types are available, types of secret. Depending on that, the data section will be changing it out. So if our secret type is basic auth means basic authentication. You can provide the username and password. Both of these value can be encoded using base 64, and you can pass it in the container using the encryption as well. Okay, this is a secret YAML file. You can see API version v1. Type is secret, metadata, name of the secret, and this is the section which is important, the type. Type decide what is coming in the last section. Based on the type, the section will be changing. Currently, I am using basic auth. The username and password is coming under string data. But if the type is kubernetes.io SSH auth, you can see the section is changing. Now it is looking for SSH private key. If the type is TLS key and cert, you can see the type is TLS, then the key and cert field will be coming in. If the bootstrap token is the type, generally it is used, if you remember, when you go and create the Kubernetes cluster using kubeadm, when the worker node joins the master, they use the bootstrap token. So this is the bootstrap type token is there, which you can use it. It totally depend on the container application, how you will be mapping the what type of secret they are looking at. So now let's go and see the presentation of secret, how the secret can be created or managed. Okay, same lab, we are continuing it. So here you can see it. I'm creating a file where I am forwarding my secret. Now using the command line also, I can go and create the secret. Using the command line also, I can go and create the secret. Or otherwise, I have kept the secret as base 64 encoded, and through that also I have created the secret. So in this example, we have created two secrets. One is DB creds, the name of the secret, and second is database creds. Now I will be mapping the secret inside my containerization application. So first I will go and create the secret. I'll go and create this file and create the secret. Okay, in my Ubuntu environment. Okay. So the secret is created. I'll just go and show you the kubectl get secret. You'll be able to see the secret kubectl describe secret db hyphen creds. If I describe it, sorry, describe secret get secret db hyphen cerds. Sorry. Okay, I just go and describe. You cannot go and find the secret. It is not showing you directly. Okay, this is from the command line how I can do it. This is something which I am doing it using base 64 encoding. The encoding value is coming here. Now this value I will go and put under my secret.yml file. Okay, in my secret.yml file, I'll go and put this value sec.yml, and you will be able to find these two values are there, username and password. Okay, but this is base 64 encoded. Now I'll go and publish this secret, mount this secret inside my containerization application, containerized application. So how will you do it? As I mentioned, secret can be mapped using volume and volume mount or environmental variable. So first we will see using environmental variable. Here you can see it. I have under the container, the env field is coming. Name, you can provide anything which you internally want to use it. Main thing is secret key reference. Name of the secret is coming, and inside the secret, what is the key you have given it. Similarly, same thing is coming here. So I'll go and create this pod. Okay, a pod, once it's created, I'll describe the pod and show you the result, and then we will see inside that. Okay, so I'll just go and describe the pod. You will be able to see that, okay, this is the thing which is coming here. Okay, set the username, set the things. So you don't need to decode it. That is, Kubernetes will take care of that thing. If it is base 64 encoded, can I use any other encryption? It is not directly supported. One second, get pods. Still the pod is not ready, looks like. Still it is creating. Just wait for a second, guys. kubectl describe pod. Okay, it is pulling the image only, is it? It is pulling the image. Looks like the image size is bigger. Okay, so you can see it was the image size was little bigger. So the secret has been populated. Now I'll go here and show you export value. You will be able to see both of my secrets will be mapped. Okay, and they will be, so here you can see it. See, this is the secret which is already mapped here, and this is automatically decoded it. So I have used the base 64 encoding, automatically decoded it, and application is going to use it. Second way to map the secret is volume and volume mount. So we will be seeing this YAML file, how we are doing it here. Okay, vi and this thing, and you can see it. I'm using the volume, I'm mentioning the secret name, and inside that location I'm mounting it out. Okay, just see kubectl create hyphen f secvol.yml pod.yml. I have created the secret. Now I'll describe the pod and I'll go inside that location and show you. Once the image is pulled, you will be automatically able to see the secrets are automatically mapped there. Okay, the secret is, now I'll go here inside that and show you the secret. It is populating there. Okay, so that is the logic here. Secrets are widely used when you are going to design a multi-tier application. So in the next session, I will be taking a full-fledged project where whatever resources I have covered it, I will try to create a full-fledged project and use all the resources or Kubernetes resources and create a full-fledged project. So you will get a good understanding how to create the project. Thank you everyone. Thanks for joining the session. I will be adding the lab links. And if any issues, please drop me a mail, amit@openwriteup.com. Thank you for joining the session. Hello everyone. In this session, we are going to discuss about the project which I told that okay, we will be covering throughout the session. So actually here we are going to develop a three-tier application. When I say three-tier application, we will be having a front end. For front end purpose, we will be using WordPress containers. Okay. Then we need a database. So DB we will be using MariaDB. Okay. And to manage the MariaDB, we will be using a PHP admin containers. So all these containers are already published. We will be using the official images and performing the things. So first of all, as I told, we will be having a Kubernetes cluster. So Kubernetes cluster is already created. Now, when you assign a Kubernetes cluster, first thing is that, okay, these all application must, if I am working in a large organization, it must be created under the namespace. So first thing you will be creating the namespace. So you guys will create the namespace. Inside the namespace, it can be in same namespace, across namespace. Currently, the scenario which I am covering it is the same namespace which we will be using it. Now we know that okay, DB is something, database is something which require which we need to map the data. Okay, they require the persistency. So we need to create the PV and PVC for the DB. Okay. Similarly, database is an application which require the secrets as well, because how I will connect the database using the secrets. So the secret parts also will be coming there. Coming to the point, PHP admin. PHP admin also has to connect to the DB. So the PHP admin will be using the DB secret and communicating it. Okay. So DB secret will be provided to PHP admin app. Similarly, WordPress also has to communicate to the DB. So DB secret app will be provided there. PHP admin, we need to have some persistency there also required for the application. Okay. Holding the PHP pages and other things. So PV, PVC, we will be using there as well. So this is the setup which we will be creating it. Now let's go with the flow, how the flow will be. First thing which you will create it, you will be creating the namespace, because before, without creating the namespace, I cannot go and provision the pod and other things. Second thing which we will be creating it, you will be creating the secrets, because the application, when the, as I mentioned in the secret sections, when I covered the chapter on the secrets, I told that secrets or config map, they will be used when the pods are starting it up. Once the pod is created and containers are running, I cannot go and modify the secret and config map. So you need to go and create the secrets first. Okay. We need to map the storage as well. So we will be creating the PV as well first before containers comes up. Then we will know that, okay, the first application where the front end will be connecting it is a DB application. So DB containers, we will be spawning it up, but we want that, okay, it should be a multiple replicas. If currently we will run one replica, so we will be using deployment. That is the easiest way to do that thing. So we will be launching the deployment. In the deployment, I initially will maintain the one replica, but later on you can change it. Okay. And since we are using replica and other things for networking purpose, we will be creating the services for that. Similarly, once DB is created, then we will be creating the PHP admin. And same thing, we will do the deployment and create the service for that. When DB wants to connect, PHP admin wants to connect the DB, it will be connecting to the DB service. Okay. Similarly, last point is WordPress. Same thing we will do for the WordPress. We will be creating the deployment and service. So ultimately, we have uh, object which we are creating it here is namespace, secret, PV, deployment, services. All this component we are going to use it and create our project. Again, the for flow purpose, I'll show you. PHP will be connecting to the DB admin. WordPress also will be connecting to the DB secret. I will be WordPress. Definitely, we need to go and launch our WordPress website. So WordPress will be having a front end. It will be using node port type service. PHP admin, choice is yours, but I will say that, okay, since you need to map the database or you may need to manage the database, PHP admin also, I'll suggest use the node port, because through that only you will be connecting it. DB internal service only. So DB will be only creating the cluster type resources, cluster service type resource. We will not create the node port and other things. Okay. So this is the project which we are going to create it. And now we'll see how these components will be working together. Okay. So let's start with the project and see how it will be working it out. So I already have things created in my Git repo. I will be sharing my GitHub repository link to see that, okay, how things has been designed and other things. So I'll just go to my GitHub repo. Just give me a second. This is my GitHub repo. Here you can see this is 3-tier Kubernetes project. So first I will be creating the namespace. Then I will be creating the PVPVC for DB and PVPVC for WordPress. Then I will be creating the DB deployment and service and other things. Then WordPress and PHP admin. Okay, let's go and do the git clone to my repository. So I will be able to show you the YAML file, how I'm creating it. So first I'll go and do the git clone and do the project starting. Okay. The project is copied, 3-tier Kubernetes project. Okay. So first is I told we will create the namespace. So this is the namespace.yaml, but namespace name is WordPress. Okay. So I'll just go and create it, create namespace WordPress. Okay. Sorry. kubectl create name is create hyphen app WordPress.yaml, w namespace.yaml. Okay. The WordPress is created. I'll show you kubectl get all hyphen n WordPress. Nothing will be there, everything is blank. Okay, now I'll go and create, as I mentioned, we will be creating the secret first. So I'll just go and create the curate secret. Okay, inside the same namespace only, create hyphen f, sorry, secret.yaml. So in the same namespace it is created. I'll just go and describe it, kubectl describe secret and WordPress, because it is created under the WordPress namespace. You can see it. It has created the secret. You can see MySQL database is there, MySQL password is there, root password and username. All this thing has been provided. Now we will be creating the PVPVC. Okay, create hyphen f PV PVC.yaml, and then same thing kubectl create hyphen f PVPVC for WordPress. Also I am creating it for mapping the PHP pages and other things. That's all is requirement. Okay, so now I have created a lot of resources. I'll just show you under the WordPress resources are created. Okay, get all hyphen n get secrets hyphen n WordPress. Okay, so you can see all the things has been created here. Okay, now let's go and start creating the resources. So first, what we will create it? We will create the DB. Okay, DB and DB service we will be creating it. So I'll just show you get svc hyphen n WordPress. You will be able to see the DB service is created and it has node port type service, cluster IP type service, not the node port. Okay, and I'll just show kubectl get ep hyphen n WordPress. So DB is ready, then it will show you endpoint here. Currently DB is not ready. kubectl get pods hyphen n WordPress. If I do it, I will be able to see that okay, it's still creating it. So once it is created it, we are good to go. Okay, it is created now. It is running. Okay. So see here, the pod is running there, IP is there, this thing is there. Okay. So it is, if I want to call this particular pod, I will be using this name of the service. Okay. Let's go and see PHP admin, this thing. See, everything is same. But when it wants to connect to the DB, when it's a PHP admin wants to connect to the DB, we are providing the secret here. See, here secrets is coming. I'm using the root credential to connect it. And as well as when the PHP admin service, okay, when the, sorry, not PHP admin service, then PHP admin, how will it call the DB, correct? So here you can see it, host is coming. This is the name of my DB service. This is the name of my DB service. I am passing it out here. So inside the container, the value will be defined. And when it wants to, container application wants to connect it, this is the DB service. This is not the pod name or container name. Here you can see it, kubectl get svc. If I do it, it is name of my DB application which whom I am creating it. Okay, so I'll just say create hyphen f php dept svc.yaml. Okay, so if everything is properly connected and everything is properly done, then you will be able to see that okay, php admin, if I will go and open it, it will be able to connect to the, using this 30081 port node port number, I will be able to map to my DB thing. Okay, I will be able to use the secret and login. So secret is I should be able to log in using root, and the password is as well. Okay, so that should be allowed if everything is properly configured. Last thing is deploying the WordPress. Again, I will show you the WordPress YAML file. Okay, here also you can see it. I have clearly mentioned the DB host name here. You can see this one is DB host name, like DB host name in the sense DB service name we are providing it. Through that we are connecting it. Okay, let's go and create the WordPress as well. Press.yaml. So all the components are created. Okay, and I'll just show you get all hyphen and WordPress. Hopefully it should show you all the components are created. And the port number 30081, if I connect it, it will be connecting to PHP my admin page. Through that, I will be able to map the DB and perform the activity. If I want to connect to WordPress, I will give 30080 port number. Let's try it out. Okay, let's open the console here and try 192.168 and just give the 3008081. Okay, so it should open. See, php admin, if at all username and password is working, then I am able to connect to my database. See here, you can see that I am able to connect my database. So this is the integration has done. So here what we did it, we have created deployment service for PHP as well, deployment service for database as well. But when PHP admin container wants to communicate to the DB, we have mentioned in the PHP admin what is the database name, service name, and through that it is connecting it. So it means cluster IP type is working. Now let me go and show you 30081 as well. 80, sorry, this is 81, this is 80. So it should launch the WordPress as well. Let's see WordPress container is running or not. It is running or not. It is running. So it will open the WordPress. See here, this WordPress page is open. And you can see here I have launched the complete 3-tier application where WordPress is connected to the DB, and I can manage the DB from the PHP admin. So this is the multi-tier application inside the WordPress namespace. So in this scenario, we have used this YAML files and done the job. Again, for summarizing the things, when you discuss, when you go and present yourself, you should know that, okay, how Kubernetes resources has been used. So here, sequence is also important. Like we have created the namespace, then created the secret PV, PVC, and then we are deploying the app. When we are deploying the app also, workload API, we have used deployment. You can use deployment, you can use replica set, replication controller. And through the service, we are communicating because the identity of the pod can be changed. And now when the things are created, like secret and PV, PVC is required before the DB application comes up. So all the sequence must be orderly performed, and that's where our new concept come, which is through Helm chart we control it, or through Argo CD we can decide the sequence. So sequence must be decided how the each of the YAML file should be executed. I cannot directly go and create the secret before I go and use the namespace, or maybe I cannot go and deploy this deployment.yaml if the secret and PVPVC is not created. So all this chapter which I covered it, I have tried to use all the YAML file and try to create a full-fledged application which is can be presented that okay, how we have developed the microservice architecture using containerization and Kubernetes. Thanks for joining the whole session, guys. as per your feedback, I will be keep on adding the sessions here. So next target will be little bit advanced. In this session only, we will go ahead and add the advanced things such as ingress controllers, different type of services and other things. So later on, I will be adding it. Currently, I will be concluding this whole session. Thanks for joining, and please provide your feedback and drop a mail if you have any issue at amit@openwriteup.com. Thank you.